What's up, everybody? This is me, Yawar Manzoor, and sorry, I'm exactly 2 minutes late. Okay, 1 second. I just need to fix everything and then we'll get started. I need to get done with this. Okay. Okay, so what's up, everybody? This is me, Yawar Manzoor, and I believe everybody of you is doing great, nice, and absolutely fine. Come on, I just need to know in the live chat how many of you are feeling great today, okay? And if I am audible and visible properly, I just need to know in the live chat itself, okay? Come on, all of you. We'll get done with this session by in next 2 hours, okay? We'll finish every damn thing. And there are so many nice questions that I'll be showing you. And this is the basic mathematics. This is what we call the differentiation or integration. Today, I'll be talking about what actually differentiation is in the real life, okay? A lot of people basically, see, if we talk about this differentiation, everybody is able to solve the questions from this portion. But the scene happens when we ask people what actually this differentiation is, okay? People lag over there. What is the real meaning of this differentiation in real life? What is the meaning of integration in real life? Okay, everybody is able to integrate bigger, heavy problems. But today we're gonna be taking the feel of what actually this concept is. What is the meaning of this concept in real life? Differentiation, integration. So everything we're gonna be talking about by today itself. Okay. That's great. Okay, yes. So shall we start, everybody? So ladies and gentlemen, boys and girls, my name is Yawar Manzoor. You can definitely read it from the screen itself. And I'm a JEE physics expert. I'm from Kashmir. And I welcome you to JEE English Unacademy. I suggest everybody of you to subscribe this channel as soon as possible. If you haven't subscribed yet, just do it right away, okay? And hit that bell notification button so that you'll get update every single time whenever we come live, okay? All of you, come on, everybody, show some love in the live chat. So this is a piece of information about me. You can definitely read it out from the screen itself. Today, we're gonna kill this entire chapter in just one shot, okay? This will be a detailed one shot, not a revision type of one shot. So I suggest you people to stay with me for the entire 2 hours, okay? So you can definitely follow me on Unacademy. This is my username over there, okay? This is my Unacademy's username, because every time we come up with some of the beautiful special classes where I show some problems on different concepts, where we come up with some courses. So I suggest you to basically follow me over there so that you will get the update over there as well. And apart from this YouTube platform, we have our own platform. That's what we call the Unacademy's platform, okay? And over there, you can take this plus subscription and this iconic subscription. Why should you basically take this plus and this iconic? Because there are so many benefits, okay? Because country's main top educators are teaching you inside Unacademy only, okay? So you'll be getting live classes every single day, weekly tests, structured courses, unlimited access, means you can watch anybody's lecture any damn time. And if you take this iconic subscription, you'll be getting all of the benefits you get in plus, and there are some extra benefits as well you get in this one. That is what we call this personal guidance. Means this personal guidance is you'll be getting an educator which will help you, who will help you throughout your exam, how you can crack any damn exam like JEE Mains, JEE Advanced, okay? So, and you'll be having the test analysis. Once you give the test, afterwards you have to analyze your score, okay? In which portion you need to work more, in which portion you are lagging in. You have to basically do the analysis. That's done by our team only, which is inside this iconic, which is inside this plus, okay? You should go for, and you'll be getting this experts guidelines, you'll be getting this study material, study planners. And if you take this Spark batch, this is the batch we have recently launched on Unacademy. This is a completely in English language, okay? I suggest you people to go and check this out, because there are so many top educators who are teaching you inside this batch as well. This is for class 11 JEE Mains and Advanced 2023. Definitely you should go for this one. And this is the batch we have launched for class 12th, okay? You should go for this one if you want to boost your rank in your upcoming JEE completely in English language. Some of the top Telugu educators are teaching you over there. Okay. And how can you enroll in our special classes? As special classes are completely free. You can come in our special classes by you have to basically download the Unacademy app. Over there, you have to log in or sign up with your mobile number, okay? And over there, you have to search my name. There is a search bar. Search my name. That is Yawar Manzoor. This is my username. You'll get a profile. You'll get my profile over there. And if you see this type of interface, click on this, see all this. These are the special classes, completely free of cost. And once you enter in any of my special classes, it will ask you for a code. You should definitely enter this code so that you'd be able to see that particular lecture for free completely. Okay. And then you can take this plus subscription for 12 months. You can take it for 18 months and you can take it for 24 months. The prices are, okay, the price are, this is 42,525. So basically this is 34,000 something. You can take basically it for 6 months, 3 months as well. EMI options are also available. You should definitely go for that. And if you want to basically get the maximum possible discount, use my code. That is YAWAR, Yawar in capitals. Okay, everybody. Okay, that's great. Come on. Is everybody doing great in the live chat? And then we have this plus subscription. If you take this, Iconic subscription for 12 months, 18 months and 24 months, you'll be getting the maximum possible discount if you use my code. This is my code, okay? For any of the subscriptions, you can definitely use my code in order to get the maximum possible discount. Now, this is the IIT JEE Mega Combat Scholarship Test. Every Sundays this happens, okay? This is, you can win up to 4 crore plus scholarship if you go for this one. Previously, it was on 22 of 2nd. So, August, now it will be on 29 of August, 11 a.m. There will be 21 questions that are asked in this one. You have to finish those in 60 minutes. And if you get the rank, according to this, you'll be getting these benefits. And these are some of the benefits you get in Amazon, okay? Fine. And most importantly, yeah, I'll be teaching for 2023, 2022 as well, chill scenes, okay? This is for everyone. Chill scenes will complete the syllabus, all of you are with one shots, quick revisions, problems, lecture 1, lecture 2 type, everything. Don't worry about that. Chill scenes. And if you find any of my content as inappropriate, you can definitely report. The link is in the description below. And ladies and gentlemen, most importantly, the people who are appearing or who want to basically get the solutions of JEE mains 4th attempt, it will be started. It will start at 8 o'clock exactly on Unacademy app. Link is in the description below. Click over there. It is completely for free. You can definitely go over there and check. Understand? JEE mains paper solution for 4th attempt. Definitely you should go for this. So it will be starting from today itself, from tonight itself, 8 o'clock. Okay? Fine. Now, this is calculus one shot. Let's kill the entire calculus in just one shot. Okay? Everybody feeling nice, everybody feeling fury, fire. Come on, in the live chat, show me something. Show me some love, bro. Okay. So, let's get started. First of all, differentiation. We'll directly start from differentiation. We'll take the real feel of this differentiation. Take the real feel of differentiation, slope, rate of change. A lot of people basically say, sir, this slope, this differentiation is nothing but it is slope. And what is the slope actually? What does slope mean in real life? A lot of people say, sir, this differentiation is nothing but rate of change. What is this rate of change? Everything we're gonna be talking about by today itself in this lecture, okay? Fine. And this is our goal. This is the first part of this lecture. That is, we're gonna be basically focusing on what actually differentiation is. Understand? Why do we study differentiation? Where does it come from? Everything. If you want to take the feel of any of the concepts in physics, you have to understand this fact. Why are you studying that particular concept? What is the application of that concept in real life? Then only you will get the feel of that concept. That's mandatory, okay? And where does it come from? What is the real feel of differentiation in real life? Okay, these are the questions that we're going to be answering in this one. So let's just begin with a story, a beautiful story that I have for you people over here. Come on, listen to me very carefully. I'm very fine. Thank you. Yeah. I'll teach from basics, entirely basics. Okay. If you get any sort of problem at any damn point, just let me know in the live chat itself. I'll repeat that. Don't worry about that. But you have to promise me you will stick with me, okay, for the entire lecture, for next 2 hours or 2.5 hours. Let's see till what time it's gonna go. So we'll kill every damn question over here. Let's kill this session and let's kill every damn problem in this one, okay? And there are some of the previous year questions that I'll be showing you in this itself. So you will kill for sure, definitely the every question. Now, ladies and gentlemen, boys and girls, listen to me very carefully. If I say, for example, I'm starting with a beautiful story, okay? You will love this story. I'm starting from A point and I'm, for example, reaching B point, okay? I started from A point. This is my house. This is my friend's house, okay? I'm going from my house to my friend's house, okay? This is my place, my friend's place. I'm starting with this car, okay? I'm riding this car from my house to my friend's house. I covered, for example, 100 kilometers of distance, okay? Fine. I covered in 5 hours. Listen to me very carefully. This is gonna give you the real feel of differentiation in real life, okay? Now, I have covered, for example, 100 kilometers in 5 hours. When I reached the point B, when I reached my friend's home, my friend is asking me the simple question, very simple question. He's asking me, bro, Yawar, what was your speed throughout this journey from A point to B point? Now, can you guys answer this question? What was my speed actually? You will say, how do I calculate this speed? Imagine you are in your 9th class right now. I'm starting from entirely basics, okay? Imagine you are in your 9th class right now. So how will you try to answer this question? You will say, if I need to find speed from this point to this point, means how fast I was going from point A to point B, I'll have to use this concept. What is that? I'll see how much is change in distance, or simply how much I have traveled the distance, okay? Total distance traveled, total distance traveled upon total time taken, okay? How much a distance I traveled from this point to this point, how much time I took, okay? This is a very simple concept. I'll definitely get it how much speed I had, okay? Fine. So total distance traveled, how much total distance I had. Can I just write the same thing like this? Change in distance. It's a very easy change in time, okay? For example, when I started from this point over there, it was distance was 0. When I reached this point, 10 kilometers, 30, 40, and 100. 1 hour, 2 hour, 3 hour, 4 hour, 5 hours, okay? So basically, how much is the change in distance in this case? You will simply say, sir, it is nothing but 100 minus 0. That is 100 kilometers. So you will say final point minus initial point, 100 minus 0 upon 5 minus 0. Can we say it like that? Change in distance upon change in time. If you write the same thing, I'm asking you to write the same thing mathematically. How can you write the same thing mathematically? Change in distance means d2 minus d1. Change in time, t2 minus t1. What was the time when you were over here? When was the time when you were over t2 minus t1? Can I just write it like this? Delta d upon delta t. 100%, no confusion in this one. Yes, so how much it will be? It will be nothing but that is 20. I'll just write 20 kilometers per hour. Ladies and gentlemen, boys and girls, listen to me very carefully. Listen to this concept. So we got this 20 kilometers per hour from this point to this point. I told him, bro, my speed was actually 20 kilometers per hour. Now you tell me one thing. What information this 20 kilometers per hour is giving us? What sort of information this is giving us? It is telling us every hour I was covering 20 kilometers per hour. For example, it was 100 kilometers per hour. So what sort of information this is giving us? That is every hour I was covering the 100 kilometers. 200 kilometers per hour means every hour I was covering the 100 kilometers per hour. Clear? Clear? I'll give you the exact feel of rate of change. Okay, you will get the goosebumps for sure. Okay, listen to this very carefully. So this is 100 kilometer per hour, 20 kilometer per hour. This is, what is this? This is basically what we call the speed. This is speed. Now, can I say it like this? Rate of change of distance with time. What is rate of change? Means with what rate I am changing the distance. Bro, 20 kilometer per hour. Every hour I am covering the 20 kilometer per hour. More is my rate of change of distance, more is my speed. Means rate of change of distance. With what rate you are changing the distance? Over here it is given 20 kilometer per hour. Now if I say it is 100 kilometer per hour, means the rate of change of distance is more. Now, if I say rate of change of distance is more, means I'm moving very fastly. Everything is clear over here. Everything is understanding what I'm trying to say basically. So what is this? Can I say this is nothing but this speed we got, this speed is nothing but rate of change. Everybody, come on, in the live chat, I need to know. Everybody, yes. So basically, this is nothing but, this speed is nothing but rate of change. Rate of change of what? Rate of change of distance with time. With what rate distance is changing with time? Here it is saying basically 20 km per hour. Clear? So what is this delta d by delta t? This is also what we call the rate of change. This is also what we call the rate of change. Understand? Rate of change of distance with time. That's why we say delta d by delta t. Afterwards, you will see what? dd by dt, instantaneous rate of change. Now, you got the concept what actually rate of change is, delta d by delta t. In future, like in differentiation, you might have seen, sir, this delta y by delta x. What is this delta y by delta x? In that case, y is any quantity, x is any quantity, means rate of change of y. With what rate? How fastly y is changing with x. Understand? At what value of x, y is having some value. Rate of change of y with respect to x. Same over here. Instead of this y, we put distance, because in this example, we have distance changing with time. So this is a rate of change of distance with time. You got the feel of rate of change. What actually rate of change of it? Come on, in the live chat, I just need to know. I just need to know, drop a crystal clear if you got the feel of rate of change. Okay, fine. So rate of change. Okay, that's great. That's great. Got the feel. Yeah. So this is actually the feel of rate of change. With what rate one quantity is changing with another quantity. In this world, there are infinite number of quantities. One quantity can change with any other quantity. We say, bro, what is rate of change? You'll say rate of change of velocity with time. How fast velocity is changing with time. That's what we call acceleration. You say in your cricket match, the run rate, what is how fast you need to score the runs in order to win the match. Understand? That is over there, it is run rate. So that's why rate of change is a gold. It's a piece of gold. You just need to basically put it in your heart. Okay, this you will see every damn time. Force is what? Rate of change. Newton's second law, F is dp by dt, rate of change of momentum with time. Understand? Current is what? Rate of change, dq by dt. Every damn thing you will see in your life, that is rate of change. Snap is rate of change, jerk is rate of change, crackle is rate of change, pop is rate of change, acceleration is rate of change, velocity is rate of change. I can tell you thousands of rate of change over here. Okay, everything. Come on. So you got the feel of rate of change. So can I say in this case, you told me the speed from A point to B point in general. So can I say this is nothing but average speed? Can I say this is nothing but average speed 100%? Now, if you are saying that this speed is nothing but rate of change of distance, so then can you say that this speed is nothing but over here, this is nothing but that is average rate of change? Clear? This is average rate of change from this point to this point. With what rate distance was changing? 20 km per hour, 20 km per hour. This is nothing but average rate of change. This is nothing but average rate of change from A to B. Clear? Now, what if I ask you to tell me the speed at any instant? Now the question hits our mind. Now you will get the feel of what actually differentiation is. See, previously from A point to B point, I told you that what is my speed? A point to B point in general, that is nothing but 20 km per hour. That is nothing but average rate of change. That is nothing but average speed. Clear? Now, the question is, what if I ask you to tell me the speed at any instant? I'm asking you to tell me the speed over here exactly. You'll say, sir, that is instantaneous speed. I'm asking you, how will you find it? Imagine you are basically 300 years before, basically trying to solve the same question. You don't have any differentiation concept yet. Tell me how you are supposed to find that. You will say, simply, sir, we'll use the previous formula. That is nothing but change in distance upon change in time. We'll use this formula in order to calculate the rate of change. I'm saying, okay, use. Let's see if we get the answer over here is not. Now, you'll say, sir, at speed, for example, I would say at t is equal to 15 seconds exactly. 15 seconds. You'll say, sir, speed at 15 seconds. Listen to this very carefully. This will give you the exact feel of differentiation, okay? You will say, sir, at this speed at 15 seconds, I would say change in distance, okay? Change in distance, no problem. Delta d by delta t, simply. Change in distance upon change in time. That is a delta d upon delta t. I got no issues. Now, what is change in distance, sir? You will say final point minus initial point. Previously, point A to point B, 100. What was your speed? What was your displacement or distance you have covered at this 100 kilometers? Initially, it was 0. Over here, time was 5 hours. Over here, it was 0. So, 100 minus 0, 5 minus 0. 100 minus, so you got 20. You tell me over here, bro, at a single point, I'm asking you, tell me how much is your speed at 15 seconds exactly at any particular point. You will say delta d by delta t, change in distance, means final distance minus initial distance. If you are talking about a single point only, how you are supposed to find the change in distance with this formula? Come on. Come on, everybody. Please teach units, measurements. First, listen to this. Previously, when I was teaching you kinematics, sir, please calculus and that. First, you listen to this. Afterwards, we'll talk about the other things as well. Come on. Can you tell me what is the speed? How can you find the speed over here? So, you will say, sir, speed at this point, you will say, what is the change in distance? Change in distance at a single point. See, if I'm talking about at this, from this point to this point, exactly when you are at, for example, this is point A, this is point B, when you are exactly at point C. At point C, exactly how much was your speed? Change in distance at single point is what? 0. Change in distance will be only when you move forward. So second point minus first point. So this much. So this much is the change in distance. Now, if you move forward, this much is the change in distance. When you are talking about the single point, change in distance is 0. Change in time is 0 because time hasn't changed. You are talking about 15 seconds only, that particular point only. So change in distance will be 0. Change in time will be 0, means it is meaningless. According to this, if we use this formula, according to this, there was no speed when we were exactly at t is equal to 15 seconds. But when you looked at speedometer exactly at t is equal to 15 seconds, it was showing 100 kilometers per hour, 300 kilometers per hour, whatever it is. By differentiation only we can find this. Yes, that's very great. Now, in order to solve this type of problem, so we are finding the speed at any particular point. Speed is what? Rate of change. Means we are trying to find the rate of change of distance over here. Simply, I would say rate of change. So, rate of change. So, we introduced the concept of differentiation. Differentiation told us, my job is to tell you rate of change at any particular point. Previously, it is easy to find the rate of change from A point to B point. We got easily that is 20 km per hour or whatever you say. We got this one. Exactly, this was the rate of change that we got. This one. But in this case, we introduced the concept of differentiation. Differentiation said, you just have to follow a few of the points, then you can get exactly this one. You will get the feel of differentiation. Now, differentiation said, okay, I'll tell you how to find the this one. So he said, for example, if from this point to this point, you are saying that time interval is basically delta t. Okay, fine. Now he said, if you are supposed to find the rate of change at any particular point, you just take one more point, just very close to it. Understand? Such that the difference between those 2 points, if I'm taking this point, such that the difference between those 2 points is approximately equal to 0. It is hell small, this difference. Okay. Now, if you got the 2 points, so can I say, if you tell me this is the difference between these 2 points, for example, the second point is at t is equal to 15 seconds, first point is at t is equal to 14.99999 seconds, approximately equal to 0 difference between these two. Understand? So now from this point to this point, how much was your speed? You were saying, sir, it is nothing but delta d by delta t. Now at t is equal to 15 seconds, at t is equal to 15 seconds, you will say, sir, simply if you are saying from this point to this point, it is a dd, large change in displacement. Between these 2 points, how much is the change in displacement? We can use the previous formula now. Change in distance, you will say, sir, it is very small, approximately equal to 0. Can I represent that with d, this d? And then change in time, you will say that is a dt. Means this is what you call the speed ins. Understood? So we introduced the concept of differentiation in order to find the rate of change at any particular point. That's why people say differentiation is nothing but rate of change at a particular point. Rate of change at any particular point, or slope at a particular point. We'll talk about that after some time. So till here, you got the feel of differentiation. Why do we study differentiation? Where does it come from? So in this example, we are supposed to find the rate of change of distance with time. Understand? So there may be infinite number of quantities. In some other quantities, we are supposed to find dy by dx. Y can be any quantity, x can be any quantity. So in that case, we use the concept of differentiation to find the rate of change at any particular point. How many of you understood this? Come on in the live chat. Come on in the live chat. Crystal clear. CC, drop it CC. Yeah, I'll tell you that also tends to 0. That's what I told you. This point to this point, delta t tends to 0. That will give you dt only, na. I'll tell you that also. Chill scene. Still here, you people got the feel of differentiation actually. You got the real feel. Yes, that's what I actually wanted from you. That's great. Okay. Now, see. So we say differentiation is nothing but instantaneous rate of change at any particular point, instantaneous rate of change. Fine. Or you will say simply differentiation we use in order to find the rate of change. So speed at any instant, we say this, you were saying delta d by delta t. If for example A to B, you are saying time interval is nothing but delta t. You will say, sir, make this delta t equal to approximately equal to 0. Very, very, very small, tends to 0. So it will give us, if you basically reduce this, you will make it approximately equal to 0. It will give you the single point. At that point, what will be the time? That will be dt. Very small time. From this point to this point, it is delta t. It will dt. And at that point, what will be the change in distance? It is nothing but a dd. That is dd by dt. This is what you were asking. So that's why in general, if we write in terms of y and x, y is changing with x. Over here, displacement was changing, distance was changing with time. Now, if we say y is changing with x, in that case, limit of a delta x tends to 0, it will give us a dx, y by dx. How many of you people got the real feel of this equation? This real feel. Come on. Okay. So people say differentiation is nothing but slope at a point. Let's get into that. Why do people say actually slope is nothing but differentiation at a point? Okay. So first of all, we need to understand this slope. Then we'll see what this differentiation actually is. Slope at a point. Now, let's understand the slope first. For example, there are two mountains over here. This is the mountain number 1. This is the mountain number 2. If I ask you the simple question, which slope you will prefer to go for a snowboarding ride, okay? Which slope you will prefer to go for a snow ride? People will say that people who are from mountain areas, they will definitely go for this one. Why? Because they know when we go for a ride through this slope only, there will be more fun because we'll be having more speed. People were saying that in previous class, sir, this is more safer. So we'll go with this one. Hey, who looks for the safety? First, we have to go for the fun. Afterwards, let's go for the safety, okay? So people will go for this one, not this one. Why? Because this is a more steeper. This is having more steepness. This is having more incline. This is more inclined. It's having more inclination. This is having less inclination. So can I say that? Can I say that in real life, this is having more slope? This is having less slope. Understand? So this steepness, we in mathematics, we have given it a beautiful name. That is what we call the slope. Understand? This steepness, how much steeper it is. This line is at 0 steeper. This is having no slope. Increase its inclination, slope is increasing. Increase, infinite slope. Understand? This is having some slope. How much inclined is it? How much inclined is it? Yeah. So now, people over here, listen to me. If I ask you to tell me how much is this steepness, how much is the slope? You'll say, sir, simple. It's very simple, okay? This slope depends upon this perpendicular. It depends upon this base. It depends upon this perpendicular. It depends upon this base. Why? Because see, length of both the slopes are same, okay? Now, if you increase this length, this perpendicular will increase. Or if you increase, If you increase this perpendicular, the slope will increase. See, increase this. This is the perpendicular, increase perpendicular, slope will increase and base will decrease. Means slope is directly proportional to perpendicular, inversely proportional to base. Understand? If you increase base, slope will decrease. Like here, base is more as compared to this one, but slope is less. It is less steeper. Here, perpendicular is less. So can I directly say this is perpendicular by base? Now you got the feel. Why do we say slope is perpendicular by base? Now. You say, sir, this slope is nothing but tan of theta, tan of theta. Okay, this is tan of theta. You tell me one thing. In mathematics, tell me a quantity which contains perpendicular upon base. You will say, sir, there is cot, there is tan. But in cot, you say base upon perpendicular. In tan, you say perpendicular upon base. So put the tan over here. Tan of theta. If I say this is making the theta. If I say this is making the theta dash. Okay. Can I say this is nothing but tan of theta? Now you will say, sir, slope is nothing but tan theta. Why do we say slope is nothing but tan theta? Because more you increase the inclination, more slope it will increase. Theta is more. Tan theta is more. Understand? Value of tan theta, check from the trigonometric table itself. Tan theta is more means slope is more. That's why we say slope is tan theta, slope is perpendicular upon base. Now if we further modify it from, if you for example say you are traveling from this point to this point, understand, in this slope you are traveling. So means you are traveling in this x, if this is x, if this is y. If you are traveling in x as well as y, because at this point, this will be having the value of y, this will be having the value of x. When you reach this, this will be the having value of x, this much is y. So means when you're going in this inclination, along that you are traveling in x, you are traveling in y. Okay? You are traveling in x and you are traveling in y. Now tell me, how much is this perpendicular? You'll say, sir, it's very simple. How much is that? You'll say, when we reach this point, from this point to this point, okay? So finally, it is nothing but, this much is nothing but, if I say over here, it is y1, over here, it is y2, okay? If I say this is y-axis, I consider it anything, dt, whatever it is. So you'll say simply, sir, it is y2 minus y1 upon, you will say, sir, this over here, it is x2, over here, it is x1. So you'll say x2 minus x1. So you'll simply say y2 minus y1, can we write delta y upon delta x? Now you got the feel of what is this delta y by delta x. This is nothing but slope between these 2 points. We found the slope between these 2 points. Hey, come on, in the live chat, I need to know. Yeah, the live chat, I need to know how many of you got the feel actually. So that's why we say tan of theta is nothing but delta y by delta x. What is that actually? That is how much is that change in y? How much is change in x? What is telling us? Slope is giving us the information how much you have traveled in y, how much you have traveled in x. Or simply, how much is the rate of change of y with respect to x? This is what previously we understood. This is nothing but rate of change. Understand what rate of change? Average rate of change means this slope is telling us nothing but average rate of change. With what rate one quantity is changing with respect to another. Hey, come on, man. Nobody will tell you this information 100% sure. Check on YouTube, okay? Go watch anybody's lecture. This information, this real life feel, you will find it nowhere in no book. 100% damn sure. Check it anywhere if you want. Go. Come on, how many of you got the actual feel of slope between 2 points, differentiation, rate of change between 2 points, rate of change at a particular point? Come on. The people who understood rate of change, according to me, understood half of the physics. Okay? This is a piece of gold. This is a piece of gold. Yeah. Okay? Yeah, loving the lecture, huh? That's great. That's great, man. Okay, tomorrow, which lecture we should go with? Electromagnetic waves. Playing with your mind, what actually that is, okay? What is a wave? What is an electromagnetic wave? The light coming from sun, is it some sort of wave or electromagnetic wave? Yeah. Chalo. Let's. So basically, slope gives us the information from this point. Slope gives us the information what? With what rate one quantity is changing with respect to another. This was the actual feel of that. Fine. Now in general, previously if I say, for example, this is delta d by delta t, in general it is nothing but, what is the slope in this case? You will say, sir, slope is nothing but, clearly I can see that is nothing but tan of theta. What is tan theta? You'll say perpendicular by base. What is that? Delta y by delta x. You got the feel now. What is this? Previously you were writing in your notebook at delta y by delta x. Now today you got to understand that what that delta y by delta x is. Okay, so this slope delta y by delta x is nothing but with what rate y is changing with respect to another, because slope is the only quantity in this world that tells you with what rate y one quantity is changing with another. Understand? With what rate one quantity is changing with another. That's why we say this slope between any 2 points, we say delta y by delta x is nothing but a rate of change. Yes, it is exactly similar to this. Compare this with the real life situation. This point to this point, we were able to find the rate of change. Okay, I'll tell you. One second. It'll create confusion. I'll have to go with the beautiful sequence that I'm going. Okay, fine. So this is nothing but delta y by delta x, I'll tell you. Now, let's move on to this one. What if I tell you this is a straight line, okay? I'm asking you to tell me the slope between these 2 points. You are saying, sir, slope is very easy. That is nothing but delta y by delta x. Okay, that's fine. That is nothing but tan of theta delta y by delta x between any 2 points. That's okay. I'm saying you between these 2 points, it will come out to be same. Between at this point exactly same. Why? Because this is nothing but tan of theta. Theta in case of straight line will be same at every point. Theta making over here, over here, over here. So in case of straight line, it is same. Now you will say, sir, real life feel. We don't want this mathematics real life feel. Okay. What is slope? Slope is steepness. How much steeper it is. If I talk about this curve, okay, this curve at this point, slope is less. At this point, more slope, more infinite slope. Understand? Now, have a look on this line, have a look on this mountain. At this point, steepness is exactly similar at this point because this is same steepness. How difficult it will be for us to climb this one. For example, if it is taking some amount of energy over here, same amount of energy it will take over, because slope is same. Over here it is not that difficult to climb. It is not that, it is more difficult to climb. It is very difficult to climb. So slope is changing, slope is same. Got the real life feel? Come on in the live chat, man. Okay, so in case of a straight line, if you want to find the slope at any point, it is same, okay? Because slope is tan theta, theta will be same everywhere. Now the point is, if I ask you to tell me the slope between any 2 points in case of a curve, you will say, sir, take that point, take the another point. Now join these 2 points, Now find the slope of this line. That will be the slope between these 2 points. A very simple, easy method, okay? You'll say, sir, this is at x1. This is at x2, fine. Now you will say, join this one. You will say, sir, what is the slope? Slope is tan of theta. So in this case, slope is nothing but tan of theta. That is what? This perpendicular. For example, if I say this is y1, over here, this is y2. So this perpendicular will be y2 minus y1. This will be x2 minus x1. Can I just say that is y2 minus y1, that is a delta y upon this a delta x. Same method between any 2 points, even in case of a curve also. Over here between any 2 points in case of a curve also. Chill scenes, no problem till here. Now the problem comes. Now the problem is when we are supposed to find the slope at a point in case of a curve. You will say, sir, slope in case of a curve is also same. How, bro? At this point, you see, less slope, theta is less. At this point, more theta. At this point, more theta. Theta is changing. Tan theta is changing, slope is changing. Come on. Understood? It's gonna be okay. Is electric field lesson completed? Almost, bro. 2-3 lectures more. That's in the electric field lecture is complete. Now we have to go for the electric potential and all. That potential energy. Okay, now how do we find the slope in case of a straight line? Listen to me very carefully, ladies and gentlemen. See, now I'll take you back to your previous times when we were supposed to find the speed from A point to B point. Okay, in that case we used the simple formula, 9th class formula, change in distance upon change in time we got. But problem came when we were supposed to find the speed at any particular point. So in that case, we introduced the concept of differentiation. Now, we also explained this scene that slope is nothing but rate of change between any 2 points. Okay, we can calculate the slope between any 2 points by perpendicular by base. Now the problem is when you are supposed to find the slope at any particular point in case of a curve. So over there, differentiation will help us to find the slope at a particular point. You will say, sir, how? Because slope is nothing but rate of change. Slope at a point is nothing but instantaneous rate of change. Between 2 points, it is average rate of change. Hey, explain now over here, man. Slope is nothing but delta y by delta x between any 2 points. At a point in case of a straight line, it is also okay because slope is same. But in case of a curve, between 2 points, we are able to find it, no problem. But at a point, problem comes. So we introduce the concept of differentiation that tells us the slope at a particular point, means that tells us the rate of change at a particular point. Come on, man. Now, how do we exactly find that same method? So we introduce the concept of differentiation because we know slope is nothing but a rate of change. A rate of change. Understand? Slope is nothing but rate of change. Fine. So between any 2 points, it is easy. Perpendicular by base. Okay. Now at a point, it is difficult. So introduce the concept of differentiation. It will tell us to find the slope at a particular point. What is that method? Take this another point. Okay. So for example, this is first point. It will say, sir, take the another point. Okay. We are taking the another point. Join these 2 points. Now, if you join these 2 points such that the difference between these 2 points is approximately equal to 0, hell small. So we will say simply it is nothing but this line will touch these 2 points at a single point only. This is first point, this is second point. For example, you take this point very close to this point such that the difference between these is approximately equal to 0. So in that case, you will say, sir, it will appear as a single point only. Yes. So if it appears as a single point only, so you will say, so the line joining between these 2 points, it will touch this point at 1 point only. So the line which is touching the curve at what point? 1 point only, we call that tangent. Okay. You find the slope of this tangent, you will get the slope at a point. Now, so we basically, this line will touch this slope at a particular point only now. At 1 point only, we call this. Now, for example, if I say this is making the theta over here. Now, do the zoomed view. Understand? So make a zoomed view of this one over here. This is the normal view, make the zoomed view. You will say if we make the zoomed view, these 2 points are very close to each other. This is the first point, this is the second point. Line joining the 2 points. Now, if I say, for example, this is at x1 distance, this point is at x1 distance, this point is at x2 distance. Okay. Now, make this one. So can I say if this is making theta, because over here, this is making theta, that is theta, this one. So this theta, understand? So now find the slope. So you'll say, sir, slope is nothing but, I'm using the simple concept. You'll say, sir, slope is nothing but tan of theta. So how much is this tan theta? You'll say, sir, tan theta is this perpendicular by base, this base. You'll say, how much is that? You'll say, sir, that is this y2 minus y1 and this x2 minus x1. Okay, y2 minus y1 upon x2 minus x1. You'll say, sir, can I write the delta y by delta x over here? Definitely not. Why? Because these 2 points are approximately equal to very close to each other. So difference between their perpendicular is also very small. Their base is also infinitely small. So in previous case, you were saying delta y by delta x. In this case, can I say if this is very small, hell small, this is hell small. So this will be dy by dx. So can we say slope at a point is nothing but dy by dx. What was this dy by dx? Rate of change at a point. That's why we say slope at a point is nothing but rate of change at a point. Differentiation at a point. How many of you people got the feel of this one? Come on, come on. Sir, you are OP today. Full form today, okay? Full form. Clear? How many of you people got the actual feel? That's why we say differentiation is nothing but slope at a point. Differentiation is nothing but rate of change at a point. All the three are linked to each other. If you say slope at a point is dy by dx, means the rate of change is also dy by dx at a point. Differentiation is also at a point. Got the feel. That's great. That's great. Yes, physics is love. If you try to understand the physics like this, you will love it. You will love it seriously, okay? Okay, let's move. Now, done with differentiation. Let me show you that the first slide. That was the concept. What actually differentiation is? Feel now you will say yes sir 100%. Why do we study differentiation? Feel, where does it come from? Feel, what is the actual meaning of differentiation? Understand? I hope you got this is clear to everybody now. Slope, you got the feel of slope, you got the feel of rate of change at a point, rate of change between 2 points, everything. Come on, show some love in the live chat. Yes, we'll cover everything, bro. Okay, it's gonna be okay. Okay. Afterwards, once we get done with this, I want everybody of you to comment down below which part was the exciting one, okay? How to differentiate. Now the point is how we can differentiate, okay? People start teaching differentiation from here onwards, okay? How to differentiate. dy by dx is what? Understand? Now, let me just give you the one more feel from this one also. So you will say, sir, y is equal to 10. What is the differentiation of this one? Differentiation of constant, you will say, sir, that is 0. What does it mean in real life? See, what is dy by dx? With what rate y is changing with x at any particular point? Understand? Rate of change of y with respect to time. dy by dx means if y is equal to 10, can you draw the graph of this one? So you'll say this is x, this is y. So y is 10 means a graph will be straight line. Okay? Y is 10. Now you tell me one thing. In this case, dy by dx means with what rate y is changing with x? How fastly y is changing with x? Okay? You will say, sir, when x is 1, y is 10. When x is 2, y is a 10. When x is 3, y is 10. Means on changing x, y is the same. What is dy by dx? With what rate y is changing with x? How fastly y is changing with x? In this case, y is not changing. On changing x, y is still the same. That's why we say dy by dx is 0. Because at any particular point, y is same, not changing. That's why dy by dx in this case is 0. That's why we say differentiation of this constant is 0. Understand? Now, if we try to look at from the graphical point of view also, you will say, sir, differentiation. Tell me the proof of from the graphics also. I'll say, okay, this is y, this is x. You will say, sir, slope of this line, this is y is equal to 10. Y is a 10. Slope of this line, you will say slope is nothing but tan of theta. So over here, how much theta is making this one? This line is parallel to this one, 0 degrees. You will say tan of 0. Tan 0 is 0. So that is slope is 0 means slope at a point is nothing but dy by dx means from this one also it is 0. How many of you got the feel of this one? Come on, everybody. Okay, come on, everybody. Yo, crystal clear. Okay, that's great, man. Clear, sir. Go. Okay, y is x. Y is equal to x. What is the differentiation of this one? What is the graph of y is equal to x? You will say, sir, it is this straight line, y is equal to x, making theta is equal to 45 degrees with the x-axis, okay? Straight line y, because y is equal to x at x. When x is 1, y is 1, means this point. When x is 2, y is 2. When x is 3, y is 3, okay? dy by dx is what? dy by dx will be 1 only, na? In terms of x, it will be nothing but 1 only. It is nothing but 1 only. You will say, sir, with what rate y is changing with x? At every point, it is changing same, na? So I would say theta in this case is 45 degrees. Tell me slope over here. You'll say, sir, slope is nothing but that is tan of theta. Tan of 45 degrees, that will come out to be 1 means dy by dx. Come on, let's move forward. Okay, come on. Now, y is equal to 4x cube. Can you tell me the differentiation of this one? Now, we'll have to solve some of the questions afterwards. We'll come back onto the field once again. We say 4x, this 4x cube. See, first of all, let me just tell you a formula of a differentiation. If, for example, if we have x raised power n, understand, any x raised power n, if I ask you to tell me differentiation of this one, you will say it's a dy by dx is nothing but differentiation of means. If I say, for example, this is y is equal to x raised power n, it's the differentiation what? Now from now onwards, if anybody asks you, you are given y is equal to x, what is its differentiation? What is the meaning of that? Means with what rate y is changing with x, how fastly y is changing with x, understand? Now in this case, its differentiation will be nothing but power down, that is n down, x raised power n minus 1. Understand? Take this n down, x as it is, this power minus 1. Understand? If I say, for example, I'll just write x cube. Understand? Now its differentiation will be nothing but, you'll say power down, that is 3 down, x raised power n minus 1, that is 3 minus 1. So that'll be nothing but 3x square. So now tell me over here, take 4 out exactly, so it'll be x cube. Can I just write 4 and it'll be, take n down, that is power down, 3x, 3 minus 1, 3 minus 1. So how much it will be? 3x square. Come on. Okay. Okay. Guys. Okay, everything okay over here? Now, you tell me one thing. Differentiation of this e raised power x, this exponential function, it will come out to be e raised power x only. Understand? E raised power ln of x, we say it is nothing but 1 by x. Come on, let's move forward. Differentiation of trigonometric functions. If you have y is equal to x, its differentiation is nothing but cos of x. What does that mean? Differentiation is nothing but with what rate y is changing with x. If I try to make the graph of this one, it will come out to be like this graph. It's called the sine curve. So over here, at every point, how fast y is changing with x, with what rate y is changing with x, that's the differentiation of this one. Graph of this will be nothing but it will be something like this only. So this is y is equal to cos of x. Its differentiation is minus sine of x. Same goes for tan of x. Its differentiation is what? That is sec square of x. Its differentiation, y is equal to sec of x. Its differentiation is nothing but sec x tan x. For this one, so cot of x, it will be minus cos x square of x. Okay, everybody. Yes. Physics is love. Physics is definitely love. Is clarity good today? Okay, I have actually changed the settings of the camera. And how do I look? Nice. It's gonna be okay. Fine. Now addition rule of differentiation. Previously it was y is equal to something, y is equal to something. What is this addition rule? If I say, for example, y is equal to sine of x plus x4 plus cos of x or something plus e raised power x, something in addition. So tell me over here, dy by, that's addition rule of, just it'll be something in addition. So what you are supposed to do, dy by dx, in that case, what you are supposed, differentiate this one plus differentiation of this one plus differentiation of this one, that's all. Okay, so differentiation of this one, you say that is cos of x, differentiation of sine x is cos of x. Previously I told you. So for this, it will be 4x, that is power down, power minus 1, that's 4 minus 1, that is nothing but 3. Understand? So it will be cos of x, it will be nothing but minus sine of x, and plus differentiation of this one is nothing but e raised power x. People actually write it d by dx of sine of x, d by dx of x4 plus d by dx of cos of x, and then write this. I'm directly writing. Okay, now I guess you are the yeah. Okay, so can I just write dy by dx is nothing but, this will be cos of x plus, this will be 4x cube minus sine of x plus e raised power x. Come on. Now subtraction rule, exactly like this only. Y is equal to tan of x plus, sorry, it'll be something like minus over here, minus sine of x, my e raised power x, ln of x. Okay, do this one, you'll get the answer. Okay, now product rule, what is this product rule and all, understand? So you can find lots and lots of questions from the book itself. So the most important part was, the killer part of this differentiation was to actually understand the feel of differentiation, what actually that is, what is the slope, because this slope, this rate of change, you will find it in entire JEE physics. That's why that was the most. These are the questions you can find lots of questions in your book, and you can kill every question. Okay. Yeah, I'll come up with the one shots, chill scenes. Okay. What is product rule? Product rule means, for example, if you have something in multiplication, like e raised power x, not plus in between or not minus in between, e raised power x multiplied by sine x, or x multiplied by sine of x, something like this only. Okay. So this is the product rule. So how we gonna basically solve? We basically in this case consider this as u, consider this as v. Depends upon you. You consider this as u, you consider this as v. Okay. So we say differentiation of this uv is nothing but, if this is u, if this is v, it is nothing but you keep this u as it is. You keep this u as it is. Then differentiation of this x, that is a dv by dx. Understand? First of all, keep this u as it is, then differentiation of this v. Then plus you keep this v as it is, then differentiation of this u. Okay, dx. Let me just show you over here. If you consider this as, so it will be dy by dx will be equal to, first of all, u as it is means e raised power x as it is. So differentiation of d by dx of this sine of x. Then plus this v as it is, that is sine of x as it is, differentiation of d by dx of that e raised power x. So can I just write e raised power x as it is sine of x, it will be nothing but cos of x plus sine of x as it is, d by dx of, it will be e raised power x as it is. You can just take e raised power x common, it will be sine of x plus cos of x. That's all. Okay. Come on, I want answer of this question in the live chat. Come on. Come on, in the live chat. Yeah, it's gonna be okay. It's gonna be okay. Okay, I want you people to solve this one as soon as possible. Can you just do it? Okay. What is the answer of this one? Okay. You need to find dy by dx. Find dy by dx. Exactly. Dy by dx. Okay. So what? First of all, you do the multiplication normally. Can we just write y is equal to, this will be sine of x plus x sine of x. Understand? Now it is in addition as well as in multiplication. So over here between these two you need to use uv rule, and in this case then multiplication, that addition rule. Okay. So can I just write dy by dx will be equal to differentiation of sine of x, that will be simply cos of x, plus in this case use uv, consider this as u, consider this as u, consider this as v. So u as it is, that is x as it is, differentiation of v. What is differentiation of v? That is sine of x, that is nothing but cos of x. Then plus this sine of x as it is means v as it is sine of x, differentiation of this is 1, sine of x, differentiation of x is 1 with respect to x. So can I just write this is cos of x plus x cos of x plus sine of x. Come on. Yeah. Let's move on to the next one. Great. Yeah. Take cos x common over here, 1 plus x. Fine. Now, this is a good question. This is a good question. I want you to solve this one. Okay. Yeah, we'll take one more riddle session as well. Don't worry about that. First of all, so now we need to basically use the division rule over here, because this is in division. This is u by v. This is u by v. It is something like x by sine of x. Understand? Something like that. I have took already. This is a having good level. Forget about this one. This is very easy. So directly I'll take that one and we'll kill. Come on. So consider this as u. Consider this as a v. Okay? Depends upon you. Now, how we gonna basically solve this case? So if we have, for example, u by v, if we need to differentiate this one, in that case, if we have a question of this form, in that case, what you are going to do is you need to basically keep this v as it is, then differentiation of du by dx as it is, du by dx, then minus, negative, not plus over here, minus, then you keep this u as it is, differentiation of v, dv by v by dx. Understand? So this is the formula that you need to basically use over here, sorry, upon this v square, upon v square. First of all, keep this v as it is, which is in the denominator, then differentiation of this one, minus, then this u as it is, this is u, differentiation of this v, and upon this v square. Let's go for this one. So over here, dy by dx will be nothing but, listen to this very carefully. First of all, v as it is, then it will be 1 plus a root of x. Understand? 1 plus root of x, and it will be du by dx, differentiation of this one. Where will I show you? Let me just show you over here. Okay, I'll just show you over here. Okay, differentiation of this one, that is u. That is 1 minus x, 1 minus root of x. Can I just write 1 minus x raised power 1 by 2 exactly? Because root x is 1 by 2, 100%. So differentiation of this will be, this is in the subtraction of this, differentiation of this is 0. Now differentiation of this will be, can I just write for this negative as it is? So it will be power down 1 by 2, x raised power 1 by 2 minus 1, power down, power minus 1, 100%. So can I, it will be nothing but minus 1 by 2, x raised power minus 1 by 2. Understand? 1 by 2 minus 1, minus 1 by 2. So can I just write it like this? This will be minus 1 by 2, x raised power minus 1 by 2. If you take it down in the denominator, it will be x raised power 1 by 2 exactly. Arey yaar. Over here, I'll show you. Come on, make the notes of this one. 1 minus root x, okay? 1 minus root x. See, for this it will be 0 minus, it will be x raised power 1 by 2, it will be 0 minus 1 by 2 x raised power 1 by 2 minus 1, 0 minus 1 by 2 x raised power minus, it will be minus 1 by 2. So it will be minus 1 upon 2. If you take it down in the denominator, you can definitely write it basically x raised power 1 by 2. It will be minus 1 upon minus 1 upon 2 root x, because x raised power 1 by 2 is 2 root x. So it will be minus 1 by 2 root x. Now come back. Come on, note it, okay? It won't come in your notes. Okay, okay. So it will be nothing but, for this du by dx, that is du by dx, it will be minus 1 by 2 root x exactly. Okay? Then minus v as it is, 1 by root x as it is, and differentiation of this one, it will be, it was over here minus, and if this is plus, it will be 1 by 2 root x exactly. Fine. Just I'll mention it. Okay, all of you understanding this one? Yeah. Okay, chalo. So let's go for this one now. Can I just write, this is the dy by dx exactly. So in this, and over in the denominator, it will be 1 plus root x exactly, its square. And then I can further write it like this. So this will be dy by dx will come out to be. So in this case, I want you people to take 1 by minus 1 by 2 root x common. 2 root x common. So it will be 1 plus this root x, and this will be exactly plus of 1 minus root x. Why minus? Because if you multiply it, it will again become the same. Because we're taking this and this common. Minus 1 by 2, it will become same. So, and in denominator, it will be nothing but 1 plus root x, 1 plus root x, 1 plus root x, its square. Now, this will get cancelled. 1 plus 1 is 2, this 2 and this 2 will get cancelled off, okay? Now, what remains over here, that is minus 1 by 2 root x. I need to add this slide. I'll add the slide over here. Okay. So what's going to come in this case? That will be minus 1 by root x. So it will be minus 1 upon root x upon this one. It will be 1 plus root x whole square. 1 plus root x its square. So can I just write, if I take it over there, it will be minus of x raised power minus 1 by 2, because this is 1 by x raised power 1 by 2. If I take it in the numerator, it will be minus 1 by 2. It will be 1 plus root x whole square. Come on. Yeah. Okay. Come on, let's go for the next one. Can you solve this question over here? Exactly. Can I just write, consider this as u, consider this as a v, okay? U by v. So what is u by v? U by v, we just write simply, all of you need to basically solve this question before I do it. Everybody, come on. You need to solve this question before I do it, okay? So can I just write it? It will be u by v is nothing but, that is v as it is, a du by dx minus this u as it is, that is a dv by dx upon this v square. 100% I can definitely write it like that. Now in this case, first of all, what is u? What is this v? V, that is nothing but, if I write dy by dx, it is nothing but this 1 plus cos of x as it is, v as it is, du by dx, that is nothing but differentiation of sine x, that is cos of x, then minus that sine of x as it is, x, u as it is, differentiation of cos of x, that is, for this it will be 0, for this it will be minus sine of x. Everybody is understanding, or anybody is having any sort of problem in any issue? Come on, do let me know in the live chat. So it will be 1 plus cos of x exactly, okay, it's square. So can I just write over here? So what it will be? It will be nothing but cos of x, multiply this with this one, cos of x plus cos square of x, and this will be minus into minus, it will be plus, this will be sine square of x. Over here it will be 1 plus cos of x whole square. So can I just write exactly? It will be nothing but cos sine square of x plus cos square of x. It will be 1. So 1 plus this cos of x upon this, it will be 1 plus cos of x its square. This and this will get cancelled. 1 upon 1 plus cos of x. Okay. We have another rule. That's what we call the chain rule. Okay. All of you in the live chat, if you can see this. So what is chain rule? Basically, we call it the outside, inside a rule. Okay, outside, inside rule means, see, how do you basically differentiate this one? It is not, see, previously you were saying that sine of x, now if you have sine of 2x square, something different, okay, in that case, how you are going to deal with this one? So simply dy by dx, for it will be nothing but, you consider this as x only, understand? What is sine of x? That is nothing but cos of x simply. Now what you're gonna do afterwards is that you move inside this angle as well. So what is inside? That is this. Differentiate this. What is inside? That is sine differentiation of 2x square is what? That is power down, power minus 1. That is 2 into 2, 4. 2 minus 1. That is 4x. So it will be 4x. So can I just write what was x inside this x? This is cos of x. It is nothing but 2x square. And this will be 4x. So it will be 4 of x cos of 2x square. Understand? So first you do one thing, you do the differentiation of this one as it is. Understand? Sine of x, that is cos of 2x square as it is. Then move inside. That's why outside, first you do the differentiation out from the outside, then you move inside. Outside, inside rule. Then you move inside, do the differentiation of this angle. Yeah. Okay, can you solve this question? This is exactly root of 3 plus x square. Can you find dy by dx in this case? Can you find dy by dx in this case? You'll simply say it is nothing but 3 plus x square whole 1 by 2. Okay, value of root 1 by 2 over here. Now what you are supposed to do is do the chain rule. That is, first you consider this as x, that's power down, power minus 1. Can you just write 1 by 2 power down and 3 plus x square as it is, power minus 1, 1 by 2 minus 1. Hey, anybody getting any sort of confusion? I need to know in the live chat. Okay, then I'll repeat this. And once you are done with the integration of this one from the outside, then you are supposed to move inside. Inside, what is inside? This one. For this, differentiation is 0. Understand, constant. For this 2x, x square is nothing but it will be 2x. Fine, that's all. So this 2 will get cancelled. So we can write this is nothing but 3 plus x square 1 by 2 minus 1, it will be minus 1 by 2. So it will be over here x. So this is minus 1 by 2. 3 plus x square minus 1 by 2. Take this in the denominator, be x upon 3 plus x square whole 1 by 2. So it will be nothing but x upon, that is root of 3 plus x square. That's all. Everybody understood this? Come on. Now, this is the question. This is a good question. I want you to solve this one. Afterwards, yeah, this was asked in JEE Means 2019. Now we are moving on to the previous year questions. I want everybody of you to solve this before I do it. Come on, all of you, the people who are watching, come on, solve this, man. We'll take the break at 7:30 exactly, okay? 7:30 exactly. And in that break session, we'll definitely have a conversation with each other. Come on, just tell me the answer of this question. It is saying that the coordinates of a moving particle, if this is a particle, okay, this is moving, understand? Its coordinates are basically, understand, or you simply say displacement in x direction is given as x is equal to at square. Displacement in y direction is given as a bt square. Okay, these are the questions given. For example, it is something like this. This particle is moving exactly, for example, like this. At this point, its displacement in x direction is at square. Y is equal to bt square. You are supposed to tell me its speed exactly at this point only. Tell me the speed exactly at this point only. Come on, how you can solve this question? I'm waiting for your answers in the live chat. Can you do it? Can you do it? Okay. Come on, ladies and gentlemen, in the live chat, and like this session. Everybody like this session, all of you. I want you to like this session. Now see how we're gonna do it. We have the x coordinate of that particle. If this is moving, understand, it's moving in x as well as in y, understand? So we are given x as well as y. Now if I ask you to tell me velocity in x direction, how can you find that? You will say simply that is, sir, dx by dt is nothing but velocity in x direction. Simply differentiation. How do you find the velocity of anybody? Differentiation of displacement, understand, rate of change of displacement with time. So that is nothing but differentiation of this with respect to time. So power down, power minus 1, at. Can I just write 2at? A is constant, take this a out. T square, what is differentiation of t square? T down, 2 down, t into 2 minus 1, that is a 2at. Now differentiation of this one, vy is nothing but that is dvy by dt. So it is nothing but that is 2bt. So you got the vx, you got vy, means at this point you got the speed in x direction, you got the speed in y direction. Now if you are supposed to find the speed, normal speed, general speed, resultant speed, whatever you say, how can you find that? V is nothing but a root of vx square plus vy square. A very simple question, man. On the same concept, question was asked in JEE Means 2019. I'll show you, okay? So v is nothing but a root of vx square. What is vx square? Vx is nothing but that is 4a square t square plus vy, that is nothing but 2, that is nothing but this 4, where is it, b square t square. So can we just write it is nothing but a square t square, 4a square t square, 4b square t square. So take this 4t square out. So can we just write it will be 2, root of 4 is 2, and 2a root of t. It is nothing but t. Take t out. So this is t a square plus b square. Come on, how many of you understood this one? 2t root a square plus b square. Exactly. Yes, yes, very nice. Yeah, exactly. Nice, nice, nice. Come on. So the question was asked on the same concept in JEE Mains 2019. I want you people to answer this question. Okay? Okay? I want you people to answer this question in that case. Okay? 2ab cos theta. Cos the angle between that is 90 degrees. Okay? Fine. That's why it's completely in x, because it's saying it's x coordinate. Okay, x coordinate. It's y coordinate. Understand? So it's x, it's y. Angle between x and y is what? 90. Come on. Oh, where is this question? Come on, tell me the answer of this question on the same concept. Which? A, B, C, D. I'm asking you in the live chat. I need to know. Come on, everybody. A, B, C, D. Which option is correct? Which option is correct? Which option is correct over here? Tell me which option. A, B, C, D. Write something A, B, C, D. Even if that is wrong, come on, I need to know. Hey man, what are you guys doing over there? Okay, let's go for the solution. If I say, for example, velocity in x direction is what? This. Sorry, displacement in x direction is this. Displacement in y direction is this. Z coordinate is given this coordinate, say, okay? Position coordinates of a particle moving in 3D are given as the speed of the particle is. You find, if you x is given, y is given, z is given, you find the speed in x, you find the speed in y, you find the speed in z, then find the resultant. That's all the same concept, okay? Okay. Now, you tell me, if I ask you what is Vx, you will simply say, sir, that is a dx by dt. Velocity in x direction, because the position coordinate in x is given as a cos of omega t. So dx by dt. Now you tell me, how do we differentiate this one? So a is constant. Take this a out, okay? What is a differentiation of cos of x? This is omega t over here. We say this is x. Consider this as x. Cos of x. Over here, you need to basically apply the chain rule. Differentiation of cos of x. You say, sir, it is minus sine of x. Okay, minus sine of x. Instead of x, this is omega t. Then in chain rule, what we exactly do? We move inside the angle also. First, we do the outer differentiation, then we move inside also. Inside is what? This omega t. What is the differentiation of omega t in terms of t? That is omega only, because of this t is given. Okay, so that is nothing but it will be omega. Can I just write simply? It is a omega minus of a omega sine of omega t. Okay, we got Vx. Now what is Vy? Can I just write differentiation of this one? That is dy by dx exactly. So what is the differentiation of this one? You will say, sir, simply it is, take this a out. Differentiation of sine of omega t. You will say sine of x differentiation, that is cos of, instead of x over here we have omega t. So that is omega t. And differentiation, move inside this angle, that is differentiation of omega t, that is omega. So can I just write a omega cos of omega t? Then Vz dz by d, arey ye t tha, this is t, dt. Okay, then you will say for this one, what is the differentiation of a omega t? It is a omega only. Understand, it is something 2x. What is differentiation of 2x? You will say 2 only. So over here it will be a omega only. Now what is the next thing? That is a v is equal to root of vx square plus vy square plus vz square. Same question was asked in JEE Mains 2019. Okay, so v is equal to, somebody is saying B. What is the option B? No, wrong. Check it once again. Check it as soon as possible. You have to solve this before I do it. B option is wrong. So it will be nothing but what is Vx? That is A omega sine of omega t minus A. So it is square. So it will become A square omega square sine square of omega t plus second one. What is B? Vy, that is A square omega square cos square of omega t. A square omega square cos square of omega t. Then plus A square omega square. A square omega square. Now V is nothing but this is take this sine square of omega t plus take this A square omega square common. A square omega square. It will be sine square of omega t plus cos square of omega t. This is sine square of x plus cos square of x. What is that one? A square omega square. So this will be 1. So A square omega square plus A square omega square. That will be V is equal to root of 2 A square twice, because 1 plus 1, that is 2 A square omega square. So for this root and square will get cancelled. So it will come out. So I can derive 2 root 2 A omega. Option C. Option C. Okay. Let's go for the next one. Yeah. GTA Rani Singh, why only omega? Which one you are talking about? Why only omega? This one. Are you talking about this one? Because it is something 2x. If I say dy by dx is what? You will say 2 only, okay? For this it is 2 only. Now previously I told you why. So that is why over here we are differentiating with respect to t. So that's why it will be A omega only. Let's go for the next one. Now differentiation of implicit functions. So let me just tell you how do you differentiate this implicit function, then we'll move on to the next one, okay? Differentiation of implicit functions. See, how do you differentiate in these cases? So what is the implicit function and what is explicit function? Previously you saw that is y is equal to sine of x. You saw y is equal to x square plus e raised power x plus sine of x, something like that. Y was from one side, x terms were from the other side, okay? They were separated. This is called the explicit function. Implicit function is from if y and x both are together from the same side, understand? So those are called the explicit functions, implicit functions, okay? Let's solve this question. How do you differentiate this one? Listen to this rule, okay? Keep this thing in your mind, how we gonna exactly solve this. First of all, if you wanna solve any of the implicit function, do one thing, differentiate this one, that is a d by with respect to x only of this x square, okay, plus x square plus differentiate this y with respect to y, understand? Differentiate this y square with respect to y, that is d by dy of this y square, and then differentiate this y inside, understand? This y with respect to x, that is dy by dx, understood? See what I am talking about. First of all, you need to differentiate this y square with respect to y, okay? Then differentiate y, not y square, y d by, you just write it like this, differentiate this y with respect to x, okay? First of all, differentiate y square with respect to y, then differentiate y with respect to x is equal to differentiation of this, it will be 0, constant 0. Solve this one. So it will be nothing but differentiation of x square with respect to x, this will be 2x plus differentiation of y with respect to y, it will be 2y, because with respect to y we are talking about differentiation of y with respect to x, that is nothing but dy by dx only, is equal to 0, okay? Fine. Yeah, it will be x minus x by y. So can I just write, so dy by dx is nothing but take it over here, so it will be minus 2x, take this over there, it will be minus 2y, this will cancel, minus x by y. Next one, can you solve this one? See what you're gonna be doing exactly over here, differentiate this x cube with respect to x, understand? Then use uv rule over here. First of all, you will differentiate this y x, remember differentiate this x, keep x as it is, understand? See, For this one, it will be 3x square, differentiation of this x cube with respect to x, 3x square plus differentiation, use uv over here, x square as it is, differentiation of y with respect to y, dy by with respect to x, because whenever you have y, differentiate it with respect to x, dy by dx, and then plus this y as it is, differentiation of x with respect to x, that is 2x, plus differentiation of this with respect to y, that is 8y, with respect to y, that is 8y, and differentiation of y with respect to x, that is dy by dx is equal to 0. This is a bit confusing. Solve this by yourself. See, what I am trying to say is that first of all, you differentiate this x with respect to x only. That is the normal procedure. And if you find something like this in multiplication, x with y, in that case you use uv rule. But uv rule you have to use in such a way so that first term you should keep as it is, because we keep u as it is. uv is nothing but u du dv by dx plus v du by dx. Okay, now in that case we write u as it is, x as it is. Okay, differentiation of y, because whenever we have y, differentiated with respect to x, okay, plus y as it is, because v as it is, then differentiation of this x square with respect to x, that is 2x. Fine, plus we are done with this one. Plus then we have this 4y square. First of all, if we have y square differentiated with respect to y, that is 8y, power down power minus 1, 2 into 4, 8, 8y. Okay, then differentiation of that y with respect to x, that's dy by dx. Now you find the dy by dx in this one, that's the answer. Okay, understood this? Come on, in the live chat, understood this? Drop a thumbs up. You need to basically see, take this term and this term over here and dy by dx from this side, then you do the simplification and find dy by dx. Understood? Okay, now we have this maxima and minima. Fine. Shall we take a break? Break 10 minutes till 7:40. Okay, till 7:40. Okay, till 7:40. I'll go out and 7:40 be ready. I want you people to come back by 7:40 itself. Okay, I'll just come in 2-3 minutes. I'll just come in 2 minutes and we'll have a conversation till 7:40 so that we can chill out, and then we'll start by 7:40 itself. Yeah, drinks break. So, people, what's going on? Yeah, hello. Okay. No, it's still 7:40, okay? Yeah, let's cross 50 likes, okay? All of you. Hit the like button as soon as possible. And share this video with your friends as well. Okay, all of you, tell me your state name. Which state you are from exactly. Everybody write in the live chat. Mars, West Bengal. Okay. Come on a chase. Yeah, I know Mars. Yeah, I know Vizag. It's somewhere in Vishakhapatnam. Am I right? I have heard about it. I have never been to there, okay? Yeah, exactly. Guys, take notes basically when whatever I'm teaching you. It's very important. You should make your notes because it will definitely help you at the end of the day. 7:40. Okay, just 2 more minutes. Let the people join and we'll start. So soon, time flies. Yeah. Division rule is very easy. U upon V. Okay, you watch it later, the recorded one. Okay, U by V. V as it is, or du by dx minus U as it is, dv by dx upon V square. Tomorrow, me and Love sir will be having a combined session, and in which we'll be talking about you people, talking to you people. We'll be having chill and all. Okay, let me just revise the division rule for this guy. It is nothing but u by v. Keep v as it is, du by dx. Differentiation of this one, then minus u as it is, a differentiation of this v upon v square. This is the example. So I suggest you to watch the recorded one later on so that you'll get to understand this more properly. Okay, let's get started. Let's basically talk about this maxima and minima. You people might have heard, okay, so you people might have heard about this maxima and minima. What actually this maxima and minima is? What is the real feel of maxima and minima? The PDFs will be available. Okay, join the Telegram channel of JEE English Unacademy. Okay, fine. Now let me just tell you with this beautiful example how you can understand the maxima and minima. This is the example. This is a normal example in order to make you understand. Okay, normal, a common example in order to make you understand the maxima and minima. Fine. See, for example, this point, this is a point A, this is point A, this is point B, this is point C, point C. I'm asking you, this point is at 30 kilometers from this point A. If I'm saying, for example, this is a reference point, this is at 30 kilometers. Okay, I'm saying that this is at 30 kilometers. Okay, fine, means 30 kilometers far from that point A. Okay, and this is at 50 kilometers far from that point, and this is at, for example, 180 kilometers far from that point. Okay, I am asking you the simple question. For example, I'm already sitting at over here exactly at point C. I started traveling from point C and I reached this point B. Okay, I started from C and I reached the point B. Afterwards, I started from B and I reached this point D. Understand? So this is my journey. I'm explaining you what is basically happening over here, what a journey I'm covering. I started from point C, I reached the point B. I started from point B once again and I reached the point D. Now, again back, I started from point D and I reached the C point once again. So this was my entire journey. If I ask you the simple question, throughout this journey, what was my maximum displacement? You'll say maximum displacement when exactly I was at point D, because this is 180 kilometers from point A. You'll say, sir, maximum displacement was 180 kilometers. Fine. Okay. I'm asking you, what was my minimum displacement in this case? Okay. You'll say, sir, when you were exactly at this position, that is point B, you will say this is minima at a point B, 30 kilometers. Okay. I'm just making you understand. This is a very common example, very simple example. It will give you the feel of maxima and minima. So in this example, what is the maximum value? What is the maxima in this example in terms of a displacement? I'm saying, you'll say, sir, maxima is this one, 180, minima is this one, that is 30. So this is the maximum value in this case, this is the minimum value in this case. Understand? So this, if I ask you, if I say, for example, for just few instance, you assume that the graph of this situation is coming out to be something like this only. Okay, now you got the feel of what is actually maxima and minima. There are so many quantities in this world. Some may be having, at some point it will be having maximum value. You'll say, at what point it is having maximum value? I'm saying at point D, at this position exactly. At this position it's having 30. Understand? This is maxima, this is minima. Now if I ask you, if I, for example, say the graph of this is coming out to be something like this. Tell me from the graphics itself, if I say, for example, this is at 50 kilometers, understand this is a displacement, this is at 50 kilometers, and this is exactly at 30 kilometers, this is exactly at a 180 kilometers, understand? I traveled from 50 to 30, I traveled from 50 to 30, then to 180, then to 180, okay, this is 180, then back to 50. Now, in this case, yeah, in this case, see, could you please tell me from the graphics itself, which is the minimum point that you can see from your eyes? Later on, we'll decide. We'll prove mathematically what is minimum and what is maxima. Right now, I'm trying to give you the feel. So you'll say simply, sir, it is this one. This is the minimum point. Understand? At this point, because this is at 30. When you are exactly at 30 kilometers, what is the maximum? You will clearly say, sir, that is, because I can see from the graph itself, this is the only point which is at lowest. This is the only point which is at highest. So I can say this is maximum. This is maximum. Understand? So this is from the graphical point of view. Now, let's move with the another example. Okay, I am riding a car. Okay, I'm driving a car. Okay, initially I'm saying, for example, my speed is, I'm driving with a speed of 50 kilometers per hour must. Okay, afterwards I applied some brakes and I decreased my speed. It became 30 kilometers. Once again I increased the speed of the car and it became, for example, 180. Understand? So my speed, velocity, whatever it is, it reached 180 kilometers. Back I took the velocity to 50 kilometers. I'm asking you in this question, in this example, what is your maxima? You will say, sir, maxima in this case is nothing but that is 180 when my speed was 180 kilometers per hour. What is minima in this case? You will simply say that is 30 in this case. So understand? So in this example, this is maxima and this is minima, 30 kilometers per hour. Understand? Now if I ask you, we'll basically draw the same situation graphically. So okay, so for example, you assume this one. Okay, I'm asking you to assume this one because this will give you the feel. So I am saying, for example, if the graph of this is coming out to be like this, so you tell me one thing in this case. You tell me one thing in this case. What was your speed initially that with you were riding with? That is 50. Okay, 50 kilometers per hour velocity versus time. Okay, then your velocity became how much? That is 30. Then again your velocity became 180 exactly. Then your velocity became 50 once again. So in this case, can you tell me what is the maxima in case of graphics also? You will say, sir, simply this, I can see this point, I can see clearly from the graph. This is at the highest point, this is at the lowest point, this is 30 and this is 180. Clear? Must, chill, fine. Now let's move on to the graph number 3. See, in this case, what was changing? Velocity was changing with respect to time. In this case, displacement was changing with respect to time. In this case, we got the maxima and minima. In this case, we got the maxima and minima. Now, I'm saying any quantity y, any quantity x is, any quantity y is changing with respect to x. If, for example, its graph is coming out to be something like this. Fine, I'm asking you, tell me the maxima over here. You will say, sir, this is the maxima, clearly, because this is the point, only point in the graph I can see which is at the highest. This is the only point in this case I can see clearly which is at the lowest in this case. Clear? Fine. This lowest, this is the highest. Okay, fine. So I am saying this is maxima and this is minima. Now let's have a look on this minima. Let's have a look on this maxima. You will say, sir, at this minima, if we draw a tangent on this minima, so if you draw a tangent on this minima, see, I'll give you the feel of maxima and minima. Till now, you got the feel of differentiation. Now see, how do we exactly understand this maxima and minima? If I say, for example, I'll draw a tangent over here. Tell me, how much is the slope of this tangent? Understand? Can you tell me the slope at this point? You'll say, sir, slope is nothing but that is a tan of theta. How much theta is making this one? This tangent, this line is making theta how much? If you want to find the slope at any point, draw a tangent. Find the slope of that line, that tangent, that will give you the slope at that point. So it is making 0 degree with this 0. So you'll say 0. Slope at this point 0 means dy by dx is 0, because slope is nothing but dy by dx, means at this point y is not changing with x. Clearly we can say, so over here, can I say dy by dx is nothing but 0 if we are talking about in terms of y and x? Yes, clearly we can definitely say it is nothing but 0. Now tell me, what is the slope exactly at this point? You'll say, sir, simply at this point also dy by dx is nothing but 0. Means I would say in case of minima or in case of maxima, both dy by dx is 0. Means from now onwards, if you are given a graph, if you are given any equation, if you are supposed to find maxima or minima, the first thing that you will do is you will find that point, that value of x where dy by dx is 0. Why that's why we say, if you are supposed to find maxima or minima, you have to find that point of x where dy by dx is 0. That will be either maxima or that will be either minima. So you find the point of x where dy by dx is 0. That will be either maxima or that will be either minima. Why? Because we confirmed it, we proved it. At a minima, slope is 0, dy by dx is 0. At maxima, dy by dx is 0. Now, people are asking for the real feel. That's why we are here. That's why we are physicists. That's why we teach physics. That's the difference between mathematics and physics. Mathematics will tell you dy by dx 0, either it's maxima, minima, now go. Okay? Don't talk about the feel and all. Physics say we'll give you the feel. Now let's move on to the feel. Moving on to the first problem. See, I'll give you three fields, okay? See, if I say, for example, which color okay. Listen to me very carefully. You are traveling from this point to this point, means from 50 to 30, understand? So 50 to 30. First field is, you tell me one thing. At this point, you'll say slope is this much. At this point, you'll say slope is this much. At this point, you'll say slope is this much. So from this point to this point, look at this curve very clearly. It is something like this. You'll say, sir, first slope is like this, then slope is like this, then slope is like this, finally slope is like this. Means slope is a decreasing. If you are climbing this wall, this curve, so it is very difficult to climb over there because slope is increasing from this point to this point. So from this point to this point, slope is a decreasing. So slope is decreasing from this point to this point. And we have studied from the kinematics that slope of displacement time graph gives you the velocity. So from this point to this point, if slope is decreasing, so means clearly at this point, slope ds by dt will be 0. Means at this point, velocity will be 0. Why is velocity 0? Because from this point to this point, clearly slope is decreasing. And slope in case of displacement time graph is nothing but velocity. Means from this point to this point, velocity is decreasing. And clearly, I can say that from this point, if this is s and this is t, from this point to this point, displacement is decreasing, velocity is decreasing. See, displacement 50, 30, 50, 40, 30, over here it is 30, and over here velocity is 0. Speed is decreasing. Sorry, displacement is decreasing, velocity is decreasing clearly. Second field, let's go for the second field. When you are traveling from 30 to 50, you can understand it like this way also. When you are traveling from 50 to 30, okay, you have to stop over here because Afterwards, you are supposed to move at 180. That is in the right direction. So you have to stop and you have to turn. So from 50 to 30, you have to stop. Afterwards, you have to go till 180. Then you have to come back. So that's why when you stop, velocity becomes 0. And velocity over here is ds by dt. That is slope at this point. That is velocity at this point. Clear? Feel? Understood this? All of you, any confusion in this one? Why is the velocity becoming 0 from this point to, why is basically slope becoming 0 exactly at this point? Why is the slope 0 at a minima or maxima? Now same goes for this point. Now let's try to understand the graph. Let's try to understand the graph from this point to this point exactly. See, from this point to this point, can we say that, can I draw it like this? You'll say it is something like this. Okay, at this point initially slope is 0. ds by dt is 0. Now, if we draw this slope over here, over here, over here. So clearly from this point to this point, I can see displacement is increasing, velocity is also increasing, because from this point to this point, slope is increasing, slope is increasing. Again, from this point to this point, can you say that slope is displacement is increasing but velocity is decreasing? Why is velocity decreasing? Because at this point ds by dt is becoming 0. That is velocity at this point, that is velocity clearly. So over here you can check slope at this point, slope is decreasing till here, because from this point to this point and 180, you have to stop and turn back, move 30, turn back, move to 30. So you will have to stop, go over there. So that's why at maximum, you can clearly say over here, the slope is becoming 0, means velocity is becoming 0. So you got the feel. From this point to this point, what is happening? Displacement decreasing, velocity decreasing. From this point to this point, displacement increasing, velocity increasing. Understand why? Because over here, from this point to this point, what do we say? Slope is increasing clearly. And from this point to this point, see, slope is decreasing. That's why becoming 0 over here. How many of you got the feel of this one? Come on. Same goes for over here. Okay. Now, you will say from this point to this point, can I say velocity is decreasing, acceleration is decreasing? Why is acceleration decreasing? Because rate of change of velocity is nothing but acceleration. So slope of velocity time graph gives you the acceleration. At this point, acceleration is 0, means v by dt is 0. Means slope at this point is 0. So from this point to this point, clearly I can see that velocity is increasing from this point to this point. See, 30, 40, 50, and acceleration is also increasing till here. And if I say from this point to this point, velocity is increasing, acceleration is decreasing, because slope is decreasing. At this point, dv by dt is becoming 0 and acceleration is becoming 0 at this point. Understand? Okay. Why can't you take class on small board? It is much interactive now, sir. Okay. So now you got the feel at this point. Why is this any sort of confusion anybody is having over here? So at this point, we say slope is 0, dy by dx is 0. At this point, dy by dx is 0. So clearly from now onwards, if we check that at maxima over here, at maxima, dv by dt is 0, slope is 0. At this maxima, slope is 0, means at this point of time, slope is 0. At this point of time, dv by dt is 0. So from now onwards, if you are given any sort of equation, you are asked to find, tell me the slope at any point. You will find that point of x. If we are talking y in terms of x, you will find that point of x over there. Dy by dx is 0. If you got that point, means that is either maxima or that's either minima. Now the question comes, how we can find even that point is maxima and that point is minima. Before that, I need to make you understand this positive slope. See, if I say, for example, this is y, and if I say, for example, this is x, and how much this is making over here, you will say theta. So remember, if theta is less than 90 degrees, tan of theta will be positive. Okay, means slope will be positive, because slope is what? tan of theta. Understand? In that case, so over here you will say, sir, what is positive slope? By this slope, understand, this is inclined slope, means this is positive slope. You are trying to climb this one. Over here, if you would say slope is what? Slope is nothing but dy by dx in this case. That will come out to be positive. Y is changing with x in this case. Can I say that will come out to be positive? Y is increasing. Change in that increasing will be what? Positive. If y is decreasing, we'll say change will be negative. Change. And this is strictly increasing over here. We'll say this is positive slope. I have to climb this. Okay. So this is positive. And if I talk about the negative slope, this is what? This is y and this is x. And if I say this is, how much is this making? You'll say this is nothing but this is 90 plus something. If theta is greater than 90 degrees and theta is less than 180 degrees, in that case you will say slope is nothing but that is negative. Understand? So clearly you can see from over here, y is decreasing with x, so change will be negative. So in this case dy by dx will be negative. So this is a decreasing. You will say if this is a mountain, you want to basically go from top to bottom, you will clearly say this is a decreasing slope, decreasing, and you want to climb this slope. So you'll say this is increasing slope, this is a decreasing slope. Okay. Yeah. Now the point comes, let's try. See, previously we got this one, that if you are supposed to find that at any point, if this is maximum or minimum, what is the first condition? You need to find dy by dx is equal to 0. If you got that value of x where dy by dx is 0, means either that is maxima, either that is minima. So how to exactly find that is maxima or minima? This is the second question. Let me just tell you. Now see, for example, if I am traveling, this is y, this is x. So if I say, for example, this is the bowl over here. Okay, this is the bowl over here. Fine. If I need to find exactly at this point, this is maxima or minima. This is maxima or minima. This is maxima or minima. So what is the first thing that you people are supposed to do is, okay, let me just tell you what is the first thing that, okay, this is the slope. Okay, at this point we know clearly that is a dy by dx is nothing but 0. Fine. Okay, we need to basically find, we'll take this, let's try to find the minima first. Understand, we don't know if this is minima or maxima. Yeah, we have already done so many problems previously. Okay, so this is from this point to this point. Okay, so we'll take this bowl, let's try to find the minimum. So first condition is we need to basically check at what point if there is dy by dx is equal to 0. If we got that point, either that is maxima or that is minima. Second point is how do you exactly find that? Now you tell me what is happening with the dy by dx over here. You will say at this point, what is dy by dx? If you draw a tangent over here, that is theta is making greater than 90 degrees, less than 180 degrees. So can I say dy by dx at this point is dy by dx at this point will be negative because slope is negative. At this point, if I take what it will be, can I say it will be nothing but dy by dx will be nothing but that is positive. So at this point, if I try to make it exactly like this, so at this point dy by dx is negative. At this point dy by dx is 0. At this point dy by dx is positive. Fine, this is happening. So what if I ask you what is happening with the dy by dx? You will say first it is negative, then it is 0, then it is positive. You will say dy by dx is basically increasing. First negative, then 0, then becomes positive. Understand? You'll say this is happening. Now if I ask you to tell me, if I ask you to draw this dy by dx with respect to x, previously this is y with respect to x. So what is happening? If I say, for example, you take this is -5, okay, over there this is at -5, okay, this is -5, this is 0, this is +5, a +2 -2, whatever it is, +5, okay. If I ask you to draw this dy by dx in terms of x, you will say, sir, it is like this. So this will be y, this will be dy by dx because we are drawing dy by dx in terms of x. Over here it is y with respect to x. Now it's dy by, because we got the values of dy by dx. So dy by dx with respect to x. Now, first of all, I'll draw it. Yeah, I have the space over here. So 1 second. You will say this is x and this is nothing but dy by dx. You tell me one thing. What is the value of dy by dx initially? That is -5. You will say something like this. This is -5. Okay. Somewhere like this. Okay. Somewhere like this. Okay. Fine. Next point is you will say that is 0 because then afterwards it's becoming 0. So finally you will say something. Next point is something like this. So can you join these points exactly? You will say this is +5, this is -5, and this is 0 over here. So if I ask you now, listen to me very carefully. If I ask you now, tell me the slope of this line. Tell me the slope of this line. Means I am asking you slope of dy by dx. Previously over here, I was asking you to tell me the slope of y. So this is a y curve. This is a y line. Slope of y. Now, right now, I'm asking you to tell me the slope of dy by dx. This is a dy by dx plotted with x. I'm asking you to tell me slope of dy by dx. You will say slope of dy by dx over here is nothing but what will be the slope of this line? This is strictly increasing. Theta is making less than 90 degrees. In that case, tan theta is positive, slope is positive. You will clearly say in this case, slope is positive. So slope of dy by dx exactly. Can I say slope of dy by, if I say slope of y, we say, what is slope of y? Slope of any line, slope is what? We say dy by dx. A slope of y is nothing but dy by dx. Now, if I say slope of dy by dx, can I say instead of this slope, I'll write dy by dx. So dy by dx of this y, if we consider this as y, so this is a dy by dx. Slope of y, if I write d by dx of y, so slope of dy by dx, I can write d by dx of this d by dx. So that is positive. Can I say this will be d2y by dx2 is nothing but positive? Hey, you got the feel, man. So d2y by dx2, if this is coming out to be positive, still we don't know if this is, people say that will be minima. We don't know yet. Let me just give you that feel. Till here, everybody understood what I exactly did? Come on, in the live chat, I need to know. Everybody understood? Yeah, double derivative. You got this one. How this double derivative exactly came? Okay, that feel you got. If people directly write, if we need to find the double differentiation of that, how this double differentiation comes, first we need to plot that dy by dx with x, then afterwards how this d2y by dx2 comes. That is the real feel. That is the exactly, what do we say? That's love of physics, understand? That other thing, first find dy by dx is equal to 0, then find d2y by dx2. That is a mathematical thing. That's a, what do we say? Okay, that's a ratta thing. Okay, this is the exact feel how this d2y by dx2 comes. Okay, now still we don't know. People say d2y by dx2 double differentiation, if comes out to be positive, we say that is minima. How? What is the logic behind that? Let me just tell you. Take this bowl only. Take this bowl only. If I take this bowl only, okay, fine. You tell me one thing. First slope you got, because of that first slope, what you got? If this is either maxima or minima, so you got dy by dx is equal to 0. Either that point is maxima or minima. Now, second slope, understand, d2y by dx2 means a differentiation. That is slope of dy by dx. Slope of dy by dx, that comes out to be positive. Tell me, from which point the graph starts increasing? The graph starts increasing. If this is this bowl and this is a this bowl, from which point? If you say from this point, next slope, first slope is this, dy by dx is 0, means we got this point. So next slope, afterwards, if a graph starts increasing, so means even if that comes after basically minima or maxima. Hey, if we take this point, after this, if I say graph starts decreasing, it should be slope of this one is basically what? It starts decreasing over here. So it is coming out, d2y by dx2 is coming out to be positive. If I say slope of this one is negative, slope of this one is positive, means first is over here dy by dx is basically 0. So next slope, afterwards, what happens? In this case, first is this one. Next slope is basically after what point graph starts increasing? Minima only. If this is minima, after this minima graph starts increasing, means next slope, double slope is basically positive in this case. So this is positive. So agar If a double differentiation is coming out to be positive, next slope is coming out to be positive. So we say that is basically minima. Come on, everybody hit the like button. Come on. Guys, you got this one. This was the very important point, okay? This was the actual feel, okay? Double differentiation means second slope is coming out to be positive. First slope is this point. Afterwards, after minima only, graph starting increasing. So that means if this is coming out to be positive, it has to be minima only. Drop CC. If not, I'll explain this once again, because this is the tough point. I feel it, okay? I'll explain this once again if not. Come on, guys. Tell me you understood this. Yeah. So now what should we do for the minima, maxima? Same thing. So we will get, in case of minima, that is negative over here. Let's go for the maxima. Okay, let's find the maxima. Minima we got. If double differentiation, that's why people said directly, if double differentiation is coming out to be positive, that is minima. Understand? Now see, in this case, if you tell me over here, what is dy by dx? If I say what is dy by dx, dy by dx is nothing but, at this point, is nothing but positive. Over here, dy by dx is nothing but 0. Over here, dy by dx is nothing but negative. Okay, if you draw the tangent, it will become negative. Okay, slope of that will be negative. So what is happening with dy by dx? First it is positive, then it becomes 0, then it becomes negative. Plot dy by dx with y. If I say this is plus 5, this is 0, this is minus 5. Minus 5, 0. So this is a dy by dx with x. So what happens first? That is plus 5. I will say something like this. What happens next? Then 0. Then something like this, negative. Okay, over here. So it will be minus 5, it will be 0, and it will be plus 5. So if you join this, be something like this. Okay, fine. So graph of this, slope of this, can you tell me? Slope of this, that is slope of dy by dx is coming out to be negative in this case, because this is strictly decreasing of negative. So slope of dy by dx, can I just write d by dx of dy by dx is coming out to be negative? So can I say d2y by dx2 is coming out to be negative? So in that case, if I take, for example, this bowl, if I take this bowl, okay, so afterwards, if this is negative, first of all, the first slope is, that is giving us this point, dy by dx is giving us 0. So next slope is coming out to be negative. From first slope, if next slope is coming out to be negative, from minima, the graph, from maxima, the graph starts decreasing. So next slope has to be negative. So it has to be, if d2y by dx2 is coming out to be negative, so it has to be basically maxima. So then maxima. I hope there is no confusion left in this one, okay? Because I have explained you till detail, okay? Now we are given a question, we need to solve this one. Come on. Yeah. Okay. Okay, fine. Chalo, we have this question. In this case, we are, okay, just tell me, I'll tell you one more beautiful concept. Keep, just will add a new slide over here. For example, if you have some graph like this, okay, something like this. Okay, something like this. Now, in this case, you will say, sir, this is minima, this is maxima, this is minima, this is maxima, this is minima, this is maxima, this. So now, in this case, you take this as, this is what we call the global minima, which is at the lowest of all the minimas, okay? And this is what we call the local minima. And this is what we call the global maxima, and other, this is what we call local minima 1, this is what we call the local minima 2, and this is called the local maxima 1. Any other maxima? This is local maxima 2, okay? It is something like that only. Keep this thing in your mind. Now, next is, if for example, we are given an equation like this, we need to basically find, in this case, maxima and a minima. Understand? So what is the first thing that we do? The first thing is, what we do exactly over here is, what is that? That is, we differentiated, that is equal to 0. So find dy by dx. Understand? So you find that value of x over dy by dx is basically 0. Once you get that point, either that point at that point is maxima or minima, you will get to understand this. So that is this one, 2x cube. So basically it is something like, I'll just write it, y is equal to 2x cube minus 15x square plus 36x plus 5, okay? Now, you tell me differentiation of this one. You will simply say, sir, differentiation of this one is nothing but 2x cube, that is 6x. And it will be 6x. Come on, I want you people to tell me the answer in the live chat. This will be negative, and this will be 30x, and this will be plus 36 exactly, okay? Can I just write it? And for this, it will be 0. So basically, this is the differentiation. So afterwards, what we are supposed to do is, you put it equal to 0, because we need to find that point of x. Over there, a differentiation dy by dx is basically 0, because at that point, either it will be maxima or minima. For example, if I say its graph is coming out to be like this, for instance, okay? Now, if I say you need to find that value of x, this is x. At this value of x, if you got this value, for example, at 2, at x is equal to 2, dy by dx will be 0. So you are supposed to find this value only. Let's find this one. If you take 6 common over here, so it will be x minus 5x. It will be x minus 5x. 5x plus 6 is equal to 0. So can you find the roots? It will be square. It is square. It's cube, na? It's square. Yeah. Yeah, exactly. So it will be from, if you find the roots of this quadratic equation, so it will have 2 roots. X is 2, so x is 3. So now, at x is equal to 2, either it is maxima, because at x is equal to, if you put the value of x is equal to here, you'll get this equal to 0, because at x is equal to only dy by dx is what? 0. At x is equal to 3, dy by dx is 0. So at x is equal to, either it is maxima or it is minima. At x is equal to 3, either it is maxima or it is minima. Everybody is understanding this one. Come on. Yeah. So now we need to basically check for at 2, either it is maxima or minima. So what do? We double differentiate. So double differentiation of this one. Now, so that will be d2y by dx2. d2y by dx2. So that will be nothing but, for this one, if we try, it will be 2x minus 5. Understand? Now we got the double differentiation. If a double differentiation is coming out to be negative, it is maxima. If it is positive, it is minima. So check for x is equal to. So first we will check for x is equal to 2. So put it over here. So it will be 2 into 2 minus 5. It is minus 1. So it is coming out to be negative, less than 0. So can we say at x is equal to 2, it is maxima? Understand? So it is maxima. So it should have been exactly something like this only. Yeah. So at x is equal to 2, it is something maxima. Let's check for x is equal to 3. So I'll just show you over here. So d2y by dx2 at x is equal to 3. So it will be, put x is equal to 3 over here. 2 into 3, 6 minus 1, that will come out to be plus 1. So that is positive. So means at x is equal to 3, it is minima. For example, it will be something like this. At x is equal to 3, it is minima. Come on, everybody of you understood? Now, if you want to find the minimum value and maximum value, you put this value in this equation, you will get the value of maxima and minima. Maximum value means basically, see, if I say, for example, okay, this is the graph. If I say, for example, at this point, it is maxima, okay, at x is equal to 2. So this is what we call the point of, if I say this is maxima, point of maxima. And this is called the maximum. How much that is, how much is the value of maximum, value of this y. So this is called the maximum. Okay, keep this thing in your mind. Okay. Now let me show you. Yeah, y max. Let me just show you the question. This was asked in, this is the advanced level question, JEE mains, something like 2016. Okay, not remember the exact date, but something like this only. Okay, tell me, this is the question from 12th electrostatics. I hope everybody can solve this one, not that difficult. So this is the practical. Why am I showing you? This is just the mathematical equation over here. Okay, now let me just show you how can we use this maxima and minima practically in the practical concepts in our physics. Okay, come on, the people who take the classes from me with us in electrostatics, I have already shown this question in the live lectures. Come on, solo. So what is basically, it is saying that the electric field strength due to a ring at a distance x from the center of the axis carrying charge q is given as this one. See what I'm trying. Electric field, you assume it is something like magnetic field. There is a magnet around it, it will be magnetic field. It is something like that. If we place a charge, if there is anybody who's from 11th class, that's why I'm saying. If there is a charge, around it is basically electric field. So if there is a charged ring, around it will be electric field. I understand, you remember this thing. So for example, in question, what is given? This is a ring, okay? At x distance, at this x distance from the center, it is saying that because of this ring, there is a charge placed on this ring. There is a charge placed, I would say, there's a charge placed, okay? There's a charged ring, okay? There's a charge placed on this ring. So because of this ring, at this point, there will be electric field. Now, it is something like, you imagine there is a magnet placed over here. At this point, there is a magnetic field. If you place the piece of iron, it will attract it or it will repel it, something like that. So now this is a charged ring. So because of this charge, at this point, there will be electric field. At what distance? X distance from the center. I'll make you understand this very depth, okay? At x distance, given, how much is given? That is E is equal to, that is nothing but K Q x upon this r square plus x square whole 3/2. Now in this case, this is basically r. R is what? R is the radius of the ring. Understand? X is this distance. Understand? X is this distance. Keep this thing in your mind. Q is what? Q is the charge on this ring. Q is the charge on this ring. K is what? K is constant. Understand? Now the point over here is that it is saying that at what distance x from the center, will the electric field be maximum? Over here we need to find the maxima. Practical example of maxima and minima. So at what distance from the center? At this distance from the center, there will be the maxima. That we are supposed to find. So what is the condition? How do we exactly find the maxima? If I say, for example, in case of a graph, okay, first thing is you find dy by dx, okay? You find dy by dx is 0. At the value of x, if I say x is equal to 2, at this value of x, if dy by dx is 0, it is basically either maxima or it is minima. The first thing is we do exactly like that. Same goes for over here. Now, here it is y with x. Y is changing with x. But in this case, E is changing with x. Because see, it is saying that at what value of x, electric field will be maximum. Means electric field is changing with x. At this x, electric field will be different. At this x, electric field will be minimum. At this x, electric field will be, for example, suppose maximum. So we need to find that value of x. Like previously, we got the value of x as over here. That is 2. At the value of x is 2, we got the maxima. At the value of x is 3, we got the minima. Where at the value of 2, it is maxima. At value of 3, it is maxima. Understand? Minima, whatever it is. So same is over here. We need to find at what value of x electric field is maximum. Yeah, dE by dx we need to put it equal to 0. Come on, I want you people to tell me what is the answer. A, B, C, D. Come on. Now, okay, we need to add the slide over here. Let me just add 2 of the slides. Okay, so what is the first thing that we are supposed to do? That is dE by dx is equal to 0. Understand? We need to differentiate this equation. We need to differentiate this equation and we need to put this equal to, okay, over here I'll just write dE by dx is equal to 0. Okay, we need to differentiate this equation and put it equal to 0, and we'll find the value of x at that x, either it is maxima or minima. Then we'll double differentiate, we'll exactly find if this is maxima or minima. Okay, so now dE by dx, let's differentiate this one. So it's difficult to differentiate this one. Let's solve. So E is what? E is nothing but kqx upon r square plus x square whole 3 by 2. Now differentiate this one with respect to x. You will say, sir, with respect to r, why don't we differentiate it? Because with respect to x only we need to find at what value of x. Don't say with respect to r, okay? So d, that's why dE by dx. So in this case, can I just differentiate it? So use the uv rule over here. Kq is constant, take this out. So it will be kq and it will be uv, and then it will be something like this, x upon r square plus x square 3 by 2. Okay, use uv, consider this as u, consider this as v. How do we use uv rule? So it will be kq and it will be, okay, so it will be dy by dx exactly. So dy by dx will be exactly, so kq, take this out as it is. So then what is uv? U as it is, u by v, differentiation of u by v, v as it is du by dx minus u as it is a dv by dx upon this v square. This is a very good question. Okay, this is a very good question. Now kq out, this u v as it is, that is r square plus x square whole 3 by 2. Okay, then differentiation of this x, differentiation of this u, that is 1 with respect to x only. Okay, then minus this x, and then differentiation of this one, differentiation of this one, differentiation of this one. How do we differentiate this one? Chain rule. First outside inside rule. First basically power down, that will be 3 by 2 exactly, and you keep this as it is, r square plus x square. Okay, I'll just place it somewhere around here. uv, u by v is nothing but u v as it is du by dx minus v d u dv by dx upon v square. Okay, now r square plus x square as it is 3 by 2, 3 by 2 minus 1, power down, power minus 1, that will be 1 by 2 only. So it will be 1 by 2 only. Everybody understanding? Come on in the live chat. So this will be 1 by 2 only, and internal differentiation, move inside. So for this, with respect to x, this is constant, r is constant. R is what? Radius of the ring, it's constant. Okay, so basically x will be, for x it will be 2x only. So x square, it will be 2x. Differentiation of this x square, that is 2x. This and this will get cancelled and it will be equal to 0. Over here we have to basically in divide, it will be v square, this v square, because this v square, so it will be r square plus x square whole 3 by 2 and whole square exactly. Fine, it is equal to 0 because dy by dx has to be equal to 0. Okay, now what you are supposed to do, this will go, it will vanish, it will become equal to 0. So eventually what we'll get over here, that is r square plus x square, and this will be nothing but, one second, so this will be r square plus x square. Okay, this 3 by 2, and this will be minus, this will be 2 cancel, 3 into x, 3x into x, that is 3x square, this 3x square, and it will be this r square plus x square 1 by 2, it will be equal to 0 exactly. This will go over here, this will go over here, it will vanish. So eventually we will get to this one. So afterwards, what we are supposed to do is, let's do the further simplification. So what we can exactly do is take r square plus 1 by 2, r square plus x square. R square plus x square common over here. So it will be r square plus x square 1 by 2 common over here. So it will become r square plus x square raised power 1 minus 3x square. It will become equal to 0. Now see why? See, I took basically r square plus x square 1 by 2 common. So when I multiply with this r square plus x square into whole raised 1 by 2 multiplied by r square plus x square raised power 1, it will become r square plus x square root 3 by 2 minus 3x square into r square plus x square 1 by 2. It will become once again. So now either this is equal to 0 or this is equal to 0. Now in this case, this cannot be equal to 0. This cannot be equal to 0. Why it cannot be equal to 0? Let me show you why. So we say this r square plus x square whole 1 by 2 cannot be equal to 0. Why it cannot be equal to 0? Means if this is equal to 0, it means that r is equal to 0. Means if r is equal to 0 means that we are talking about this point. R is the radius of this ring. This is a ring. In question it's itself saying that it's a ring having charge q. Means then it will be point. R is 0 means point. But there is no point. In the question it's given that it's a ring. So r cannot be equal to 0. This point term cannot be equal to 0. But this can be equal to 0. So can I just write r square plus this x square minus 3x square is equal to 0. Now find the value of x over here. We'll say r square is equal to, this will be 3x square minus x square, that is 2x square. So x will be nothing but, this is r square by 2 and its root. So r is nothing but plus minus r by root 2. X is nothing but plus minus root 2. Come on, how many of you understood? Yeah, it's plus minus root 2 exactly. Means that r is equal to sorry, not this one, this one. X is equal to r by root 2. Understand? Means at this value of x, either it is maxima or minima. Understand? Either it is maxima or minima. Still we didn't prove it. Either it is maxima or it is minima. Now the point is, because we got the value of x, now the point is, how can we exactly find the maxima or minima? For that we have to double differentiate. Now you need to double differentiate what? Dy by dx. You need to double differentiate this equation. Once you double differentiate this equation, it will come out to be what? Minima. So over here d2e by dx2 will come out to be negative. We don't have to do that much of this because it's gonna take a lot of time. You can do that by yourself. Okay, so that will come out to be negative. So it is actually maxima. So means x is equal to r by root 2 is the maximum value of electric field. At that point electric field will be maximum. Yeah. If you see, every question becomes easy. You just have to use your mind accordingly. Understand? So before this, it was looking very tough. So if you know the approach, how we can interact with this question, if you know the basically strategy, how we can play with this question, then everything becomes easy. That is the main point. Understand? Now, if I ask you what is actually the differentiation, you will just tell me in just few seconds. Okay? Why? Because you know the approach now. This is how we actually understand physics, how we go for the concepts. Now, let's come on to the integration. Okay, it's gonna be okay. Fine. Let's go for the integration now. So what actually integration is? Let me just tell you in the beginning itself what actually integration is. So first of all, with the same example, with the field, real life example, what is that field? All of you, listen to me very carefully. We are starting the new portion now. That is the integration portion exactly. Come on, listen to me very carefully. Listen to me very carefully. Okay. Now, I'll give you the real feel first. What actually integration is? What does it mean in real life? Then we'll move on to the other stuff. Now, if I say, for example, I'm traveling from A point to B point, understand? I'm moving with a constant velocity, 100 kilometer per hour, okay? And I traveled for 5 kilometers, must, okay? Now, if I ask you the simple question, I'm asking you the simple question over here, that is, how much a displacement I have covered from A point to B point? You'll simply say, sir, displacement is nothing but velocity multiplied by time. How much from A point to B point, how much was velocity and how much time? You'll say simply that is 100 multiplied by this 5. You will say simply that is 500 kilometers, for example. Okay, chill. So displacement covered in this case is this much. Now, same. Okay, let me show you graphically. If I say, for example, the graph of this is coming out to be like this, velocity time graph. Velocity is constant 100, so it is something like this. For how much time? By 5 hours. Okay, so graph is something like this. Now, if I ask you to tell me what is the area under this graph, you will simply say the area under this graph is nothing but, you will say that is area is nothing but length into breadth, length into breadth. How much is length over here? You will say, sir, that is 5. Breadth is how much? That is 100. So it is nothing but 500 exactly. Fine. Clear? It is 500. Now, if you look at this one, so it is 500, it is 500. Means the area under velocity time graph, represents what? That represents displacement. So this is nothing but a displacement covered by body. Now, from now onwards, if you have something like a graph of a body, velocity time graph of a body, and if you find the area under that line, area under that curve, if you have a graph, if you find the area under that curve, so you clearly say that this is giving you the displacement. This is giving you the displacement over here, because we proved 500. We plotted the same situation graphically. So the displacement came out to be over here, came out to be the same area over here. That is this much. Okay, let's go further. Another example. Now, if I travel from A point to B point exactly. Listen to me very carefully. Listen to me very carefully. Okay. If I travel from A point to B point, in this case, velocity is not a constant. Velocity is not constant. I'm saying that A point to B point for 5 hours, for example. If I ask you, tell me from A point to B point, displacement covered. Displacement covered. You'll say velocity multiplied by time. Can I use that formula right now? Can I use that formula right now? No. Because what will you put the velocity of value? Over here, velocity is something like 50. Over here, it is 60, 70, 80, 0, 5, 4, 3, 2, 1. So what will you put the value of velocity over here from A to B? Now you got the confusion over here. What am I supposed to put? Now, in order to solve this problem, we have to do some tricks. We have to use some tricks that will lead us to the integration. What is that? Let me just tell you. This will give you the real feel of integration. Listen to me very carefully, okay? Listen to this. Listen to this. What is the actual meaning of this? Yeah. Listen to this. What is the actual meaning of integration? Now, if I say, for example, from A point to B point, time interval is, for example, it is a delta t. Fine. From A point to B point, general. T1, T2. T2 means T1, that is time interval. Large time interval, delta t. Fine. I am asking you to do one thing. You reduce this time interval. You decrease this time interval. Decrease, decrease, decrease. You make it approximately equal to 0. Approximately equal to 0. Delta t tends to 0. Okay. So when you do that, you will basically get this one single point. One single point. You agree with me? One single point. So from this point to this point, time interval is delta t. At this very small point, or between these 2 points, if you take the another point also, at this point, can I say that time interval will be hell small, infinitely small? How do we represent that time interval? That is a dt. Fine. Listen to me very carefully. That is dt. Now the point over here is, for very small time interval, can I say velocity is constant? Because from A point to B point, for delta t time interval, velocity is changing. Because we said velocity is not a constant. Velocity is a variable. Okay. So velocity is variable for delta t time interval. For very small time interval, it is constant. Why? Because it is consider it the instantaneous velocity. How much that will be over here? 50 meters per second. At a For a particular point, it will be have some value, and that's constant. That's why from here to here it is changing. But for very small interval, you can definitely take it as a constant. So if I say at this point velocity is nothing but that is constant for this very small interval of time, or instantaneous velocity, that is v. Fine. Now you got the constant velocity, you got the time interval, you can find displacement, because this formula you can use if you have constant velocity, time, you can use to find the displacement. Now we can find this displacement over here. Can I say displacement will be nothing but velocity into time? So how much is velocity? V. Time is a dt. Now for very small time interval, how much a displacement it will cover? Very small, infinitely small. So can I say that that will be nothing but ds instead of s, because from this point to this point it is s. So at very small time interval it is a ds. Fine. Now do this process once again. So find over here also, for this very small time interval, velocity will be again constant. So find ds once again at this time. Similarly over here, So you divide from a to b this infinite number of dt time intervals. You find from a to b infinite number of ds. Now I ask you to add all of these infinite number of ds's which are infinitely small. Now the problem comes here. Listen to this. This is a next level story. This is a beautiful story. Now the problem comes here. How do we add these infinite number of small ds's and which are infinitely small? We have this summation. We cannot use this one because for infinite number of ds's and infinitely small, very impossible. What to do? Now we introduce the concept of integration. Today you will get to know what actually this integration is. People say integration is area under the curve. Yeah, hence comes the use of integration. Yeah. So what is this integration? We introduced the concept of integration. Integration told us I can help you in order to add all of these ds's, even if this is infinitely small, even if there are infinite number of ds's, I am here to do that only. So it said, so integrate, so add all of these ds's from a to b, so that is ds, all of these ds's is nothing but integration of what is this, v dt from a to b, or from t1 over here if it is t1 to t2 from a to b. So can I say this is nothing but s is equal to integration of from t1 to t2, you say a to b, whatever it is. So because this is s total, integration of ds, you adding a ds is from a to b, it will give you total displacement, because from a to b it is total displacement, s total, so it will give you v dt. So this is the use of integration by adding very infinite number of small ds's. So over here integration came into play. So from here also you will get to understand this point, that if you are supposed to find velocity, displacement is given, you differentiate. Understand? You find slope. Now if velocity is given, you are supposed to find the displacement, you integrate, you do the reverse process. Why? This is the field. This much of physics I cannot explain in kinematics, so try to understand this over here itself. Okay, so why do we basically integrate velocity with times to get the displacement? This is the logic. Understood? Come on, how many of you are actually loving this? Come on. That's great if this is crystal clear. Fine. Now, if I ask you, we plot the same situation graphically over here. Yeah. So if I ask you, we plot the same situation graphically over here, you will say, okay, we plot the same situation graphically over here. It'll be something, for example, if the graph is coming out to be some curve, not the constant, okay? Velocity is even changing, not uniformly, okay? Not the straight line, it is some curve. For example, if I say something like this, okay? Fine, I'll just make it something like this. Arey yaar. Okay, something like this. Fine. Now, if I ask you, tell me graphically, the graph of this is coming out to be something like this. Tell me what is basically the area under this curve. You will say, okay, area under this curve. And you'll get to understand today that why do people say integration is nothing but area under the curve. You'll see. So this is the velocity time graph. Okay, now if I ask you to tell me the area over here, previously we were supposed to able to find easily the displacement, normally easily able to find the area of this situation also by using length into breadth, because this was straight line. Even this is a triangle, still 1/2 base into altitude, no problem. So right now it is a difficult situation. We solved this. It is difficult situation in terms of graph also. How can we solve? Here also integration will come into play. Understand? Now, so what we are supposed to do exactly over here? Now you will say, sir, we can divide this in two strips. Not possible, okay? Because this is a curve, okay? If you divide this in two strips, you will say, for example, we'll take these rectangles. So in rectangles, you are supposed to take this much only. This much only. So where will this go? And over here, it will be this much only. Where will this go? Where will this go? Understand? So that's why. So what you will do exactly, you will divide this in rectangles only, but infinite number of rectangles. Understand? So infinite number of rectangles. So if we are taking, for example, this rectangle over here, fine. This is the rectangle I am taking over here. So if I say, for example, from this point to this point, time interval is delta t. If you keep on reducing this one, so how much will be the width of this one? That is dt, because from this point to this point, it is delta t. So width is a dt. Now you tell me one thing. At this point, why do we take infinitely small? Because this curve over here will behave approximately a straight line over here. This will behave straight line over here. So can I say at this point, velocity will be nothing but v only? Understand? Because velocity will be having some value. So from this point, if you keep on reducing this time interval, at this point, velocity has some value, 50, 60, 70, bigger value, but that is constant. That's why I'm saying it will have some. You'll say, sir, if this is infinitely small, velocity should be also infinitely small. No, bro. At a very small time interval, velocity will, car is moving with some variable velocity, but for very small time interval, it is having constant velocity, but having some value. Okay, you need to keep that thing in your mind. Okay, so velocity is this one. Now tell me area of this rectangle. You will say, sir, area of this will be very small area. That is nothing but dA. Understand? So it is nothing but length into breadth. Length is what? This v. From this point to this point, it is v, and this is d, v dt. So previously I told you in previous example, area under velocity time graph represents what? Displacement. Told you clearly previously. So this will be nothing but ds, very small displacement. Now similarly, you find the area of this rectangle. Understand? You find the area of this rectangle, you find the area of this rectangle, add all these areas to get the total area. So how do you do that? By integration, because integration help us to find the area under the curve also, because it's not easy. So because we'll cut this in infinite number of small rectangles, integration will help us to add all of those infinite number of small rectangles. So integration of, that is dA, from, for example, this is a1, a to b, for example, so from a to b exactly. So it will be integration of v dt, integration of ds from a to b, from a to b. So can we say it will give us exactly, can we say it will give us exactly the total area, that is a total, or a displacement total is nothing but integration of v dt. Fine. That's why you might have studied in your okay, that's why you might have studied in your kinematics that area under velocity time graph gives you the displacement. So this is the feel. This is the feel. How. Okay, I'm clearing the kinematics also over here. Okay, so that everything will be clear. Now, in general, now we got the feel. In general, any quantity y is changing with x. Any quantity y is changing with x. For example, that is something like this. Something like this. Okay, you need to basically find the area under this curve, the area under this curve, the area under this curve. Okay, so how can you exactly do that? You will simply say area under this curve. So it will be, for example, dx, very small distance, dx from this point to dx, this point, it is delta x, and over here what will be the value of y? It is y. So can you tell me the area over here? This will be dA of this strip. It will be nothing but, that is y dx. Now, if you want to find the total area from this A to B or from x1 to x2, what you are supposed to do, integration of dA is nothing but integration of y dx. So it will give you total area. So from x1 to x2, it will give you nothing but integration of y dx from x1 to x2. Now you got the feel what actually this is, because I have told you previously this in real life examples with the real feel. Now people say it in general. Y in terms of x. Now what is this y? Y can be any quantity. Velocity, time, that I told you previously. I hope you're loving this lecture. So we say we use integration to find area under the curve. What is that actually? What that represents actually area under the curve? It depends upon if this is velocity, if this is time. Area under the curve represents displacement. If this is acceleration, if this is time, area under the curve represents change in velocity. Completely depends upon the situations. In general, we say y is changing with x. In that case, if you are supposed to find area under this curve, that is nothing but integration of y dx. Understand? Now, what actually this is, I have given you the feel. Now, what is integration? Multiple definitions. First is we can use the integration in order to add the infinite number of small elements. First thing, okay. Second thing is we can find area under the curve integration. Okay. Third thing I'll tell you. Okay. So people basically say this integration is nothing but reverse. People say, let me just tell you, people, what do people say? People also say this, that integration is the reverse process of differentiation. Let me tell you why do people say it like that. See see, why do people say it like that? Okay, let me show you over here. If I say, for example, I have a displacement, okay? Displacement, if this car is traveling from this point to this point, okay? Displacement is changing with time. In this case, if you are supposed to find the velocity, what will you do? You will simply say velocity is nothing but d. For example, if you are supposed to find velocity, what you will simply do, you will differentiate this ds by dt. What you will get? This velocity. Fine, chill. And previously I told you, if velocity is given and you are supposed to find displacement, you will do integration. Fine. Now, if velocity is given and you integrate, what will you get? Displacement. Means, can I say, integrate, if there is a quantity x, understand, displacement, you differentiate it, you get velocity, you get rate of change. If you differentiate that rate of change, if you integrate that rate of change, integration of this rate of change, you get the displacement back. That's why we say integration is the reverse process of differentiation. Come on, how many of you actually understood this? Reverse process, displacement, velocity. Again, integrate, you will get the same function back. That's why in generalized form, y is equal to f of x. Y is any quantity, f of x. If you differentiate it, you will get f dash of x. Now, if you integrate it, this f dash of x, this rate of change, if you integrate this rate of change, you will get back f of x. You will get back f of x. That's why integration is the reverse process of differentiation. Yeah, we are getting s in terms of t over here. If you integrate this in terms of t only, you will get s. Same like you differentiate this one. If you are differentiating in terms of t only, so over here in terms of t only, you integrate this one, so you get s back. This is what you are asking. Okay. Now, if you have any quantity s, we have s. Differentiate it, you will be getting ds by dt. If you have this ds by dt, that is velocity, integrate this, you will be getting s back. Okay, let's take the example. If you have this y is equal to cos of x, okay, can you tell me what is the integration of this cos of x? That is, you will be saying dy by dx is nothing but that is minus sine of x, clearly over here. Now, if you integrate this sine of x minus sine of x over here dx. What will be the integration of sine of x? For now, you say that the integration of sine of x will be nothing but it will be cos of x minus cos of x. This minus and minus cos of x, it will be nothing but cos of x. Okay, plus c, we'll talk about that later. So what is this? Exactly this one. Okay, fine. I told you what is this exactly. Okay, let's understand this also. For example, if this is a line, we say y is equal to x. Okay, if I ask you to tell me the slope of this line, means you are telling me the integration. Okay, integrate this line graphically. Okay, if I ask you to tell me the differentiation of this line, that is dy by dx, means you are asking me to asking me the slope of this line, that is slope of this line. So that is the meaning of a differentiation graphically. Now if I ask you one thing, to tell me the integration of this one, you'll say integration of this one will be nothing but that's area under this line. If you say the slope is differentiation, so area under this line will be nothing but integration. That is graphically. Now the question is how to integrate. Okay, we'll have to solve some of the questions and we are done with this. Everybody understood? Come on, 5 minutes break. It's 8:55. We'll start by 9 o'clock. Okay, we'll exactly start by 9 o'clock. This is the last one and we are done with basic mathematics. Yes, yes, you should. Because you are definitely getting the next level content. How many of you are feeling hungry right now? Okay. I need to eat mutton, man. I'm waiting, eagerly waiting. Once I get done, I'll go to kitchen. I'll have to grab that. Thanks, man. Okay, it's gonna be okay. Okay. And I missed the gym from last 7 days, okay? Anivia. Hi, Anivia. What's going on? We are very tired, okay? Everybody over here. Okay. मैंने पूछा. No problem. It's very difficult to pronounce your name. Akshita. Akshita. Is it Akshita? Yeah, you should. Yeah, hi. Natural music. Okay, Akshita. It'll be done. You're gonna do that. Tomorrow we'll be having a casual conversation, me and Love Sir. Okay, we'll be coming live at 9, something like 9 o'clock. We'll have a chill session. Most probably there is that game, that's what we call the guess the gibberish. Not sure exactly what is this the exact pronunciation of that. Guess the gibberish. So we'll be mostly playing that only. Okay. Yo. Yeah, Love Sir is live right now. I cannot tell him by today also that postpone your class or something like that. He'll kick me. Yeah, definitely. So I'll tell him later that I couldn't finish on time. Yeah. It's gonna be okay. It's gonna be okay. Let's start, guys. Let's finish this as soon as possible. Okay. How to integrate. Now, this is basically, so there are two types of integrations. That's indefinite integration and definite integration. Let me just give you the example. Definite integration is what? When we have limits, we are basically integrating something from this limit to this limit. For example, I'm asking you integrate x square from 0 to 2 dx. Okay, so this is what we call the definite integration, and indefinite integration is x square dx. You don't know from where to where you are supposed to integrate. That is indefinite integration. Let me just give you the real life feel also, because we believe in real life feel. We are not the mathematics people, we are physics people. So we say v is nothing but 5 meter per second over here. Find displacement. Find displacement. Understand? So velocity is 5 meter per second, and I'm asking you to find the displacement in that case. Okay, so if I ask you to tell me the displacement, you'll simply say, previously I told you, if you're supposed to find displacement, you need to integrate velocity v dt. Understand? So can I say s is nothing but integration of that is 5 det? So can you tell me how much that will be? It is nothing but s is equal to, it will be 5t. So 5t, you are not getting the exact value. Understand? Now, if I ask you the question, v is equal to 5 meter per second, real life example of a integration. Find displacement from 0 to 5 seconds. Okay, now this is basically, so basically we say s is nothing but integration of v dt from 0 to 5 seconds. You tell me one thing in this case, s is nothing but, that is 5 dt from 0 to 5. It will be nothing but 5t from 0 to 5. Put the limits over here. Afterwards, I'll tell you how do we integrate. First of all, I'm making you understand what is this integration. I'll tell you afterwards how do we integrate this one. Arey yaar, I did the mistake over here. It has, yeah, it is 5t only. Okay, sorry, no mistake. Okay, so over here it is 5t, exactly. So can I say this is 5 multiplied by this will be how much? 5 minus 0, so 5 into 5, can I say this is nothing but 25 meters, exactly, okay? Yeah, it is nothing but 25 meters. So you got the exact value over here, okay? So car was traveling from this point to this point. So you are supposed to tell me from 0 to 5, how much seconds? 5 seconds. 5 seconds, exactly. So this is the exact value. This is what we call the definite integration. You are getting some value that's having a definite value. Over here, you don't know how much exactly you are supposed to find out. Understand, this is indefinite integration. You got the feel of this one? Very cool and simple example of real life. Now, if we have something, this x raised power n, how you can integrate this one? Simply, its integration will be nothing but x raised power n plus 1 upon n plus 1 plus c. Plus c is necessary. If you have, for example, x square, so its integration will be nothing but x raised power n plus 1, 2 plus 1 upon 2 plus 1, that is x cube by 3 plus c, plus c, plus c. You'll say, sir, why plus c? Anybody know why plus c? Because I don't know. I want to know from you people only, okay? Come on. Let me just tell you. If I say, for example, I have y is equal to x square. Listen to this very carefully. Why do we write this plus c? If I have y is equal to x square plus 50, y is equal to x square plus 5000. Okay, these are the three functions we have. Okay, these are the three functions we have. This is first, we'll talk about the indefinite integration. We'll solve some of the problems from indefinite integration, then definite integration. We'll put the limits as well. So if we have y is equal, these are the three functions. If I ask you to differentiate these functions, you will say simply differentiation of these functions is dy by dx will be, I'll tell you why do we write this c. Why do we write this c? Dy by dx is nothing but 2x. For this, dy by dx will be nothing but 2x only, because for this it is 0, constant 0. For this, dy by dx is also what? 2x only. For this 5000, it is 0. Now the question is, basically, if differentiation of this is a 2x, if you integrate this, you should get back x square, because integration is nothing but reverse process of differentiation. Everybody is basically familiar with this. I have told you this before. Now integrate this 2x, integration of this 2x and this dx. Fine. So what, how much it will be? Take this 2 out. So integration of x will be x square by 2. This. So we got x square. So first condition, okay. So we got this first function back, y is equal to x square. No problem till here. Chill scenes. So in this case, can you integrate this one? Okay, if this is dy by dx. So if we integrate this one, we should get back x square plus 50. Let's see if it comes. So it will be integration of this 2x dx. So it will be nothing but, again, it will be only x square. So not 50. It should come 50 only, na? It should come 50. Yeah. Oh, it should come 50. So can I say over here, if we integrate this 2x for the third equation is 2x. So we should get back x square plus 5000. So we are getting exactly only x square. That's why we put plus c, because the c can be anything. Because the differentiation of this c is 0. That's why we are getting this and we are getting x square only. So that's why. So we put this x square so that the value of c over here can be something. We don't know, 50. So in this case, it is 50. In this case, 500, 5000. In this case, it is 0. Everybody understood this one. Everybody understood this one. Come on. You got the feel. Why do we write c? Why do we write c? Why do we write c? That's great. Now, can you integrate this one? So this is nothing but, we know integration x raised power n plus 1 upon n plus 1. So we can definitely write it x raised power 1 by 2 integration dx, because root of this is 1 by 2. Okay. So it will be nothing but, that is x raised power 1 by 2 plus 1 upon 1 by 2 plus 1. So it will be nothing but x raised power 3 by 2 upon 3 by 2. It will be 2 by 3. It will be nothing but 2 by 3 if you take it over there. So it will be x raised power 3 by 2 plus c. For this one, can you just write it integration of x raised power 1 by 2 in denominator dx? So you can definitely write it integration of, take it over there. So it will x by raised power 1 by 2 plus 1 minus 1 by 2. If you take it over there, it will be x raised power minus 1 by 2 plus 1, x raised power minus 1 by 2 plus 1 if you integrate it afterwards. Okay, then it will be plus c. Solve this. Similarly, let's go for this one. Okay, so integration of this e raised power 7x, e7 e raised power 7x. Okay. So integration of this e raised power 7x, take this 7 out, e raised power this 7x dx. Understand? So when you were supposed to differentiate this e raised power 7x, for example, so you were saying differentiation of this is nothing but e raised power 7x only, and the differentiation over here in multiply in this one. So chain, something like that, chain rule. Okay, so over there you are writing this 7, so then 7 e raised power 7x was the differentiation. Same is the case over here, but you need to write the differentiation in denominator, not the integration. So for this one, it is 7 only. So e raised power 7x integration will be e raised power 7x only. Understand? Integration of this one is also e raised power x integration is e raised power x only. So for e raised power 7x, e raised power 7x only. But for then you go inside this angle and you take the differentiation of this 7x, that is what? 7, write that in denominator, not the integration, but a differentiation of this 7x, that is 7. This cancels, e raised power 7x. Understand? In this also, you getting me what I'm trying to say? If we say, for example, e raised power 14x, its integration will be nothing but e raised power 14x only, and differentiation of this 14x in denominator, that is 14, plus c, plus c, plus c. For this one, 1 by x, see, we know differentiation of, we know differentiation of dy by dx of log of x is 1 by x. Now if you integrate this 1 by x, you will get log of x. So it is nothing but log of x, ln of x, log of x, whatever you say. Okay. Thank you. May God bless you too. Love you too, guys. Okay. Lots of love from my side also. Means a lot. Thank you. Yes, yes, yes. Plus C, plus C. Sure. Okay. Now, integration of trigonometric functions. Integration of sine of x minus cos of x sine x plus c, tan x, this one for this one, this one for this one, this one for this one. Okay, fine. Now let's go for this. Okay, waited a lot for this, but you were not present in the class. Okay, we started the class at 6 o'clock itself. Okay, now addition and subtraction rule, same in case of integration also. There will be something in addition. Previously it was y is equal to sine of x, y is equal to cos of x, something like that. Now it is in this one. So integration of this one will be, so integration of this one will be, it will be nothing but integration of this sine of x dx plus integration of x cube plus integration of e raised power minus 4x dx is equal to, understand? So this is I. So I will be nothing but integration of sine of x is nothing but minus cos of x plus it will be x 4 by 4 power plus 1 upon power plus 1 plus e raised power minus 4x upon minus 4. Understand? Because for this e raised power minus 4x integration is e raised power minus 4x only, and then differentiation of this one will be in the denominator. So I will be nothing but minus cos of x plus x 4 by 4 and minus, this will be e raised power minus 4x upon this 4 plus c. Can you solve this question? Can you solve this question? This is an x over here, x, this is x. Come on, tell me what is the answer of this question and what is the answer of this question. Can you solve this at your own? I'm waiting for you people to solve this. Yeah, so very simple. Okay, very simple. So first of all, you need to solve this one, then go for this one, then go for this one. For this, they go, it is integration of, I'll just show you over here. Okay, I'll just show you over here. Integration of 8 by x, integration of 8 by x, understand? So this is a dx. Can I just take this 8 out, 8 integration of 1 by x dx. So it is nothing but 8, 1 by x, that is integration of 1 by x, that is ln of x, ln of x clearly. So for first one, it is 8 ln of x. Then let's go for the second one, integration of 5 upon x square dx. Can we just take this 5 out, integration of 1 upon x square. Take it in the numerator, so it will be x raised power minus 2 plus 1 upon minus 2 plus 1, because when you take it over there, it will be x raised power minus 2 plus 1 upon minus 2 plus 1. So it will be nothing but 5 minus 2 plus 1, that is minus 1, x raised power minus 1 upon minus 1. So when you take it down, so it will be nothing but minus 5 upon x, minus 5, this minus will go over and it will come down, it will be x raised power 1, so it was minus 5 upon x, already minus there, so plus 5 upon x. Then let's go for this, it is 6 by x cube. So can we just integral dx, can we just write it like this, take this 6 out and take it over there, it is integration of 1 by x cube dx. So 6, take it over there, it will be x raised power minus 3 plus 1 upon minus 3 plus 1 plus 1. Okay, so it will be nothing but 6, it is x raised power minus 2 upon minus 2, 2 1s 2 3s, so it will be nothing but, I'll just write, it will be nothing but that is 3 upon minus 3 upon this x square. When it goes down, it will be minus 3 upon this x square. Okay, so it will be minus 3 by x square. Check, plus c, plus c, plus c. All of you, very simple. Okay, same you need to go for this one. Okay, this is 3 root of x, understand, this is cube root of x, this 3 root of x over here. So first you go for this one and then you go for this one. Same is the case over, you take it over there and go for this is x raised power 1 by 2. Now let's go for this one. So over here, same that what rule, chain rule, whatever you say. So take this basically 9 out and integration of sine of 3x dx. So 9, integration of sine x was what? That is minus cos of, and this is 3x, it will be 3x only. Sine of x integration is cos of x, minus cos of x. Sine of 3x is minus cos of 3x, understand? And integration or differentiation of this one in the denominator, that is over here 3. 3 1s, 3 3s. So it will be 3 minus 3 cos of 3 minus 3 cos of 3x upon nothing. So it will be nothing but minus 3 cos of 3x. Okay, check if I'm doing it correctly. Plus c, all of you, okay, because I'm going very fast. Yeah, exactly. Now can we go for this one? So it will be nothing but 4 integration of e raised power minus 7x dx. So 4 integration of minus 7x, how do we write this one? It is e raised power minus 7x only upon this minus 7x. So can we just write 4 minus 4 by 7 e raised power minus 7x plus c. Okay, now we have this definite integration. Now we need to put the limits, that's all. Okay, that's all of you. Now go for this one. So it will be nothing but integration of, first of all you need to put the integration, afterwards you need to put the limits. Okay, so can we just integrate this one? It will be nothing but x raised power 1 by 2 plus 1, 1 by 2 plus 1 upon 1 by 2 plus 1. Okay, then plus 2x square by 2 plus 3x, and it will be 1 to 9. So this will be get cancelled with this one. So you got what I'm doing exactly. First we integrated this one, secondly we integrated this one, thirdly we integrate this one. Limits are from 1 to 9. We need to basically put the limits. Okay, so now in this case, can I just write this is x raised power 3 by 2 upon 3 by 2, and I'll just write 2 by 3 exactly over here. So it will be x raised power 3 by 2 upon 3 by 2. When I take it in the numerator, so it will be 2 by 3 upon x raised power 3 by 2 plus this will be x square plus 3x upon 1 to 9 exactly. So I can definitely put the limits now. So this is 2 upon 3. So there are 2 ways you can put the limits. First you put the upper limit in all the 3, then subtract the lower limit in all the 3. That is the first method. Second method is you put the limits in first one, subtract the limit and put the lower limit, and then in this one, then in this one. Understand? Separately. It's one and the same thing. Answer will be same. So first it is 9 raised power 3 by 2. 9 raised power 3 by 2 minus 1 raised power 3 by 2 plus. So this is for the first one. Either you do it like that or that, completely depends upon you. 9 square minus 1, 9 square minus 1 square for this one. Put the upper limit over here, lower limit over here, plus 3 into 9 minus 3 into 1, like this. Okay, get the value of this, that will give you the answer. Similarly, you go for this very simple questions, that's why I'm going very fast. Now we need to go for the product rule of integration. Understand? Once we get done with this, that's all. Everybody till here understood what I am doing exactly? Any confusion in this one? So first what you need to do is you need to integrate this one, then integrate this one, then integrate this one. After simplification, now put the limits. First of all, you put the limits in this x, okay? The upper limit, then minus lower limit, okay? Put the lower limit, then plus for the second term. You put the upper limit over here, then minus lower limit over here, plus. Then you put the upper limit in the third one, then lower limit in the third one, minus of lower limit in the third one, okay? Done. Either you do it like this, like put the upper limit in all the three first, then subtract the lower limit in all the three. Either you can get the answer like that also, not a problem. Very simple questions. You can solve the lots and lots of questions from the book itself. Okay, now see what is basically product rule of integration. There is no division rule in integration, only product rule. Listen to this very carefully. I need to show you this. Okay, now see, if I say for example there is something x sine x, this is in the multiplication, this is not x plus sine of x. Understand? Integration of x plus sine of x dx. In that case, we'll integrate this separately, masla khatam. But this is something different, x multiplied by the sine x. And over here you need to keep one thing in your mind, that is you cannot keep this as u and v. Understand? We can basically, we have to take this u and v, but it completely depends upon a rule which you are supposed to take u and v according to that rule only. I'll tell you. So there is a rule, that is what we call the ILATE. Okay, ILATE rule. Okay, this is the inverse functions. Okay, whatever you say, like sine inverse of this. Understand? Cos inverse of this. Okay, these are the inverse function. This is the logarithmic functions, ln of this, log of that. Okay, this is the algorithmic functions, this x square x and all. T is the trigonometric function, sine of x, tan of x, cos of x, and e is the exponential functions, e raised power x, e raised power 3x, something like that. Okay, now if for example you see over here there is this arithmetic functions, sorry, not algorithmic functions, this is the logarithms for arithmetic functions. If you see this arithmetic function over here, and if you see this trigonometric function over here, fine. So this is this. So which function comes first, this one or this one? See, trigonometric functions comes after this x. So in this case, which comes first? This one. So you have to take this as u. So over here we have to take this as u, you have to take this as v. Understand? Now if we have something e raised power x into sine of x, in that case which comes first? Trigonometric function comes first, so we have to take this as u, and this comes after this trigonometric function, so we have to take this as v. So this is u, this is v. Understood? Come on. Come on. Okay, this understood. Come on, drop a yes or no. Then we will move forward accordingly. Yeah. So let's go for basically this one over here. So I'll take this as u, I'll take this as v. I told you according to the ILATE rule. Now what is this? What is the formula for u and v? Let me just tell you. So we say u v is nothing but integration of this u v is nothing but, that is u as it is. Understand? Integration of v dx. Keep this thing in your mind. U as it is, integration of this v dx. Understand? Then minus negative integration of, that is differentiation of du by dx, means the differentiation of this one, and integration of v dx and whole dx. Understand? After this integration. So first of all, keep this u as it is over here, then integrate this v with respect to x. Understand? V dx negative. Okay, then take the bigger integral. When you take the bigger integral, inside this bigger integral, differentiate this u with respect to x. Afterwards, integrate this v dx. Afterwards, integrate this v, and whole integration you will do it later on. Okay, let me just show you in the question itself. Now we have this x sine of x. So first of all, keep u as it is. Over here, u is x. So I would say integration, I is nothing but, this is I is nothing but, can I say it u as it is? U is what? U is x over here, x as it is. Fine, all of you. Let me just change this one. See, we say I is a nothing but, that u as it is, x as it is, integration of sine of x, that is integration of this v dx, minus negative integration of bigger integral. Listen to this very carefully, okay? Integration of bigger integral, that is du by dx, means a d by dx of this x, d by dx of this u, du by dx. Then integration of this sine x, once again v dx sine x, this because v is sine x, so it will be sine of x dx over here. Then again the total one, that is nothing but dx. Fine, last dx. Solve this, done. Question done. So I is nothing but, this is x, I is nothing but x, sine of x, integration of sine of x is nothing but, that is minus cos of x exactly. And then it is negative over here. Integration of dx by dx, understand, differentiation of x with respect to x, that is 1 only. And this is integration of sine of x, that is minus cos of x, and this dx over here. Fine, this dx over here. Now, can we just write x is equal, this is minus x cos of x negative. One second. I'll just create the space. So I is equal to this x minus x cos of x, then this minus will come out, it will become plus integration of cos of x dx exactly. Fine, now go for this integration. So I can write x is equal to minus x cos of x, then cos of x integration is sine of x, so this is plus sine of x plus c. Okay, everybody done? Come on, everybody done? In the live chat itself, I want to know. In the live chat itself. Okay, plus sine x plus c. So this is the method. If you have any sort of confusion, you can definitely repeat. So what I am basically trying to say, I is equal to, okay, I'll show you in the next question as well. I don't want to repeat now. Now, e raised power x into sine of x. Okay, this is the next one. So can I say use that ILATE over here as well? So what is sine of x? Trigonometric function, exponential function. So this comes first. So we need to take this as u. We need to take this as v. Okay, according to this. So what is uv? uv is nothing but u as it is integration of v dx minus integration of du by dx integration of v dx. This is differentiation of this one, v dx and whole dx. Now I'll go for this color. Okay, so can I go for solution now? Definitely. This is a very important one. Okay, we won't be able to solve this properly. So there is a trick that we're going to be exactly doing in this case. So we say this is I is equal to this one. We need to integrate this. So now what is this? Sine of x as it is. Because why? Because u as it is, integration of e raised power x, integration of e raised power x dx minus integration of d by dx of sine of x, that is differentiation of sine of x, differentiation of u, that is integration of e raised power x dx whole dx exactly. Now, so I can write this sine of x exactly, e raised power sine. What is the integration of e raised power x? It's e raised power x only minus differentiation of sine of x, that is minus cos of x. So it will be nothing but, integration of minus cos of x, and integration of e raised power x, it will be e raised power x only, and again this is whole dx. So I will come out to be, understand, integration of this and this. So I will come out to be e raised power x sine of x. Okay, this will come out, this will become plus, and this is integration of e raised power x cos of x exactly, this is whole dx. Now again, we need to use the same formula. Yeah, you'll get the PDF in JEE English Unacademy, okay? Or in my Telegram channel itself. Now, e raised power x into sine of x. Once again, we need to use it. It is exactly like this. Over here, it was sine of x into e raised power x. That's why I told you it's a bit tricky, okay? In this case, you need to use again uv in this one. So which we need to use basically as u and v. Over here, we need to take this as u and this v. Why? Because this is a trigonometric function. This is the another function. What do we say? That exponential function, okay? This is u, this is v. So I will come out to be e raised power x. This is sine of x as it is. Now, in this case, plus do uv. You need to basically use uv once again. You need to use uv once again. Now, for that, take this u as it is, cos of x as it is, integration of this e raised power x minus integration of a differentiation of cos of x, that is minus sine of x, okay? Because a du by dx, differentiation of cos of x minus sine of x, and this integration of e raised power x dx, this is the bigger integration, and whole dx exactly. So I can write I is equal to e raised power x sine of x plus so it will be cos of x into e raised power x. Integration of e raised power x is e raised power x, e raised power x into cos of x exactly, and over here I can definitely go, this will be plus integration of sine of x. Over here, integration of, it will become plus integration of differentiation of sine of x is minus cos of x. Okay, it should be negative over here. It should be negative over here. Did I make any mistake? So integration of this, okay, we'll solve this from over here once again. This is creating the problem, okay? Let me just solve it once again. All of you, listen to this very carefully. That's why I told you this is a bit tricky. Not, you just have to keep this thing in your mind. There should be no problem in the sign, okay? So now over here, can we just write, this is cos of x as it is, integration of e raised power x dx, and then it will be minus integration of d by dx of this cos of x exactly, and it will be exactly integration of e raised power x dx, and it will be whole dx exactly over here, okay? Fine. Now we need to go for this. So I will come out to be e raised power x sine of x. Everybody understanding what I'm trying to say? Come on. In the live chat, I just need to know. हम सबको अच्छे लगते हैं, okay? Okay. It's gonna be okay. Okay, that's great. Fine. Okay. Come on. It's love you too. So plus. Oh, it has to be negative over here, okay? Arey yaar. Differentiation of, see, over here it has to be positive because differentiation of sine of x is cos of x, not minus cos of x, okay? You should tell me in the live chat itself. That's why I was getting this hell lot of confusion over here. So it has to be negative over here, okay? Everybody listen to this very carefully. See, sine of x e raised power x as it is minus integration of differentiation of sine of x, and this will be like this. So sine of x integration of e raised power x as it is minus differentiation of this sine of x, that is cos of x only na. So cos of x into e raised power x. Now we need to go for this one. That's why. So it has to be negative over here. That's why I was getting confusion again and again. Why isn't the answer coming over here? So it is basically negative over here. Okay. It is negative, so it is negative. So it will be cos of x. Now it is clear. So integration of e raised power x, it's e raised power x only. So it will be e raised power x, and this is minus integration of that is this is integration of d by dx of cos of x, differentiation of cos of x, that is minus sine of x. This is not confusing. Just have to go in a proper way. Okay, integration of this is e raised power x only, and this is a dx. Okay, so this will come out. So I is nothing but e raised power x sine of x. This is negative, and this is cos of x into e raised power x. This will come out. This will become positive. Integration of again e raised power x sine of x into dx. Fine. Now integration of e raised power x into sine of x. Integration of e raised power x into sine of x. We reach the same once again. Now you multiply this over here. This inside, can we just write I is equal to nothing but e raised power x into sine of x, e raised power x into I is equal to e raised power x into sine of x, e raised power x into sine of x, then negative, and it will be cos of x into e raised power x, cos of x into e raised power x, then it will be negative of this e raised power x into sine of x, e raised power x into sine of x. Okay, check it by yourself at home. Okay, and it will be integration only dx. Okay, so we consider this as I. Why do we basically consider this as I? Because sine of x into e raised power x is nothing but I. So I is nothing but e raised power x is into sine of x minus e raised power cos of x into e raised power x minus this I. Because of this we write I, because initially we are taking this as I. Integral this, take it over there. So it will be 2I is nothing but integration of x sine of x minus cos of x. Everybody listen, look at this afterwards at your home. You are sitting inside your home only, not in class. So I will be nothing but e raised power x by 2. Take this e raised power x common, be sine of x minus cos of x. Exactly. So this is the integral. Okay. It was messing with us. A chill scenes, yaar. See. No need to basically confuse yourself over here. The first thing is, listen to this. Sine of x into e raised power x, u into v. Okay. So keep u as it is. Listen to me. I'll clear it once again. Keep u as it is. Integration of v. Okay. V dx, that is e raised power x dx. Then integration of, bigger integration, d by dx of sine of x means integration of this sine of x, because this is u. D by differentiation of this sine of x, then integration of v dx accordingly. Sine x as it is, integration of e raised power x is into e raised power x only, minus integration of this differentiation of sine of x is what? This integral outside. Differentiation of sine of x is what? That is cos of x. So cos of x, integration of e raised power x dx is what? E raised power x only, and this dx as it is. So integral as it is. Now, so what happens over here? I is equal to e raised power x as it is, sine of x as it is. Now minus integral of this integral of e raised power x into this cos of x dx. So once again it is of this form only. So use u into v once again. Once you use u into v once again, so same. So I is equal to e raised power x sine of x as it negative. This negative. Start the bracket over here. Okay. Now once you use u into v over here, so u is this, v is this. Keep u outside. So u as it is, integration of v dx minus bigger integral, this bigger integral, differentiation of this u, that is cos of x, integration of v dx, because integration of v dx, that is integration of e raised power x dx, and outside this dx, outside this dx. Fine. Afterwards, e raised power x as it is, e raised sine x as it is, this negative as it is, cos of x as it is, integration of e raised power x minus differentiation of this cos of x, that is minus sine of x, this integral outside, integration of e raised power x, that is e raised power x dx. Afterwards, e raised power x as it is, sine of x as it is, negative as it is, cos of x as it is, e raised power x as it is, this negative will come out, this will be positive, this e raised power x as it is, sine of x as it is, dx. So it is again of the form e raised power x into sine of x. So we take I is equal to e raised power x into sine x as this one, I. Now instead of this, we'll put basically I. Let's go in the next slide. So this one I already explained. Instead of this, we'll take basically I. So e raised power x into sine x, e raised power x into cos x, minus of this I. So if this is minus, take it over there. It was already I because we were running it as I. So take it over there. So it will be 2I into e raised power x into sine of x into cos of x into e raised power x exactly. So take this e raised power x in the common in these two and take this 2 over here. So e raised power x divided by 2 sine of x minus cos of x plus c. Come on. Now you understood this? Explain this once again. Come on. Now understood? Drop a CC. If not, tell me. Okay. Now we have this. This is the important one, okay? Afterwards, how many questions do we have? This one, this is the application part. 2, 3, JEE mains question. Okay. 3, 4 questions we have now, but till 10 o'clock, we'll definitely finish it, okay? These are some previous year questions. That's why we need to focus on that one. Now see, over here, we need to put the limits. That's why this is a bit important. So I can definitely write it over there, over here. So this is use UV over here. Now I'll go with the speed of light. I won't explain it that much. So this is UV is integration of, it is nothing but integration is nothing but U as it is integration V dx minus integration of du by dx into integration of v dx whole dx. I'll go with the speed of light. I won't explain that much. So now in this case, can I say, now use the ILATE over here, ILATE. So over here, which we need to basically put as u. So we need to basically put this as u, put this as v. So now I need to change the color. So now u, that is x square as it is, limits will put later, okay? Limits will put later. I is equal to, so x square as it is, integration of sine of 2x, integration of sine of 2x plus, not a plus, it is minus. It is supposed to be minus only. So this is minus, okay? This is integration of d by dx of this x square, then minus integration of sine of 2x. This is a dx whole dx exactly. Fine. So I will come out to be x square. Okay. So this I will come out to be, this is x square. Sine of 2x is nothing but integration of sine of 2x is nothing but that is minus cos of 2x upon this differentiation of this 2x, that is 2 in denominator. Fine. Yeah, and differentiation, integration of differentiation of 2x is nothing but 2x, and this will be, yeah, minus integration of this sine of 2x is nothing but minus, why is this minus over here, man? This minus shouldn't be over here. Yeah, integration of this is nothing but cos of 2x upon this 2, and this will be dx exactly. This and this will get cancelled. So I will come out to be x square by 2 minus of x square by 2 minus will come out this x square by 2 cos of 2x, and this is integration of x. This will be cos of 2x dx. Again, you need to use u into v over here, okay? So I will come out to be x square by 2. This is minus of x square by 2 cos of 2x, and it will be integration of x into cos of 2x, integration of x into cos of 2x. So again, we need to use the ILATE rule over here. Negative should be over here, negative should be over here, negative should be over here. Okay, so this negative will come out. It will become basically positive. It will become basically positive, okay? So what happens over here? It will be nothing but x as it is, cos of integration of cos of 2x dx minus integration of d by dx of x, d by dx of this x, and integration of cos of 2x dx, understand, and whole dx outside. So I will come out to be minus x square by 2 cos of 2x plus it will be x cos of 2x, so it will be sine of 2x, integration of cos of 2x, it is sine of 2x upon this 2, okay, then it will be negative of, this is differentiation of this is 1, differentiation of this is 1, integration, so this is 1, so integrate differentiation of this is cos of 2x, this is sine of 2x by 2 exactly, fine, and it will be dx, okay, yeah, cos of sine of 2x by, yeah. Now let's go for the next one. So I is nothing but, I will be nothing but x square minus x square by 2 into cos of 2x minus x square by 2 into cos of 2x minus x square by 2 into cos of 2x plus x by 2 into sine of 2x plus x by 2 into sine of 2x plus x by 2 into sine of 2x minus cos of minus, this will be integration of sine of 2x is minus cos of 2x by 4, so it will be plus cos of 2x by 4. Why cos of 2x by 4? Integration of sine of 2x is cos of 2x by 2 into 2 into 2 will be 4, and this is this one. So what are the limits basically? From 0 to pi by 4, from 0 to pi by 4. Till here everybody understood? Till here everybody understood? Come on. So I can definitely write I is nothing but, now see, you need to put the limits, now. Important thing is you need to put the limits, okay? Now when you put the limits, first limit in first one, that is pi by 4 whole square, that is pi square upon 4 into 2, 8, pi square by 8, okay, pi square by 8 into cos of 2 into pi by 4, that is cos 90, so cos 90 is 0, so this will become 0, so when you put the first limit in this one, it will become 0, okay, fine, so I'll just write 0 over here, it will write 0. When you put the second limit over here, it is 0. Instead of this x, you will put 0, so it will become 0, only 0, so it will become 0, okay, minus 0, okay, 0 minus 0. So first thing is gone. So now put the over here, so it will be plus pi by 4 into 2, that is pi by 8, okay, first limit, sine of 2 into pi by 4, sine of 2 into pi by 4, that is 2 into 2, that will be pi by 2, that is sine 90 into 1, it will be pi by this only. When you put the 0 over here, this will get cancelled, so because of this limit, and this will be plus, fine. So now when you put 0 limit in this case, when you put first pi by 4 limit in this case, it will become cos 90 by this, it will become 0, so because of this limit, it will become 0. Now when you put 0 in this case, 2 into 0 is 0, so cos 0 is 1, so it will be 1 by 4, that will be minus 1 by 4, because this is minus, so this is 0 minus 1 by 4, okay, understood what I exactly said? Fine. So I will become, it is pi by 8 minus pi by 4. Let's go for the next one. Okay, this is the important question. You need to basically solve this at your own. Come on, do let me know what is the answer. This is the application part. This is the application part of calculus, okay? This is the application part of calculus. Yeah, your battery 3%. Chill scenes, not a problem. Now see, we need to go for this one. So acceleration of a particle moving along x-axis, okay? Acceleration of a particle moving along x-axis varies according to the law, that is A is equal to 2v. So there is a particle that is moving along x-axis. Its acceleration is given. A is equal to minus 2v. Understand? This particle is basically moving. Understand? Its acceleration is A is equal to minus 2v. Fine. In meter per second square. And now at any instant t is equal to 0. For example, at any instant t is equal to 0, it is passing the origin. Okay. For example, if I say this is the particle, it is moving with the acceleration minus 2v. Okay. For example, at this point, this is the origin. At x is equal to 0. At origin we take x is equal to 0. So when this passes this origin at x is equal to 0, at t is equal to 0 exactly, time was t is equal to 0 when it passes through the origin. It is given in the question itself. Okay. So at that point of time, its velocity was 2 meter per second. It passes through it with a velocity of 2 meter per second. Remember these because we need to use this only in order to solve the question. Acceleration of this particle is 2 meter minus 2v. Understand? When it passes the origin means x is equal to 0, at t is equal to 0 exactly, its velocity was 2 meter per second. We need to find velocity v as a function of time, position x as a function of time, velocity as a function of its position. These are the things we need to exactly find over here. So first thing is, we'll find basically what is basically the velocity as a function of time over here. Can we just write A is equal to dv by dt? Exactly. In order to find velocity as a function of time, we can use this equation. How much acceleration is given? Minus 2v. Just put over here minus 2v is dv by dt. Fine. Very simple. I'll make it very simple. Just we have to do the differentiation stuff, integration stuff. That is all. Because we know acceleration is nothing but rate of change of velocity with time. Now take it over there and keep it over there. So minus 2 dt is nothing but, it will be nothing but dv upon this v. Fine. So now do the integration. Now you will say, why sir you are doing the integration? Because if acceleration is given, velocity we are supposed to find, we need to find velocity as a function of time. Acceleration is given, so we have to do the reverse process. Understand? We do integration. If velocity is given, we are supposed to find acceleration, we do differentiation. Okay. Now what do we exactly do over here? Take this minus 2 out, integration of dt. This is integration of dt is equal to integration of dv by v. Now look at the situation. What is given in the limits? You tell me one thing. It is saying that at x is equal to, at time t is equal to 0, its velocity is 2 meter per second. Means at x is equal to 0 also, when time is equal to 0, it was passing through the origin with velocity 2. Means at time t is equal to 0, its velocity is 2. Its velocity is 2 because passing through the origin at that time, velocity 2. When its time is, for example, after time t, for example, I would say velocity is v. Simple. Now do the integration. So can I just do, it'll be t from 0 to t exactly. So it'll be nothing but 1 by v. Integration of 1 by v into dv. That is log of v, ln of v. So I will just log of v. It'll be from 2 to v. Put the limits over here. So it'll be minus 2t is nothing but, it'll be log of v minus log of 2. Okay. So it'll be minus 2t is equal to log of v minus log of 2. Can I just write it? Log of v by 2 exactly is minus 2t. Can I just write it like that? Okay, that's great. Can I just write it like that? 100%. So if we take e from this side, can I just write e is equal to log of v by 2 and is equal to e raised power minus 2t. So log to the base e, that is equal to 1. Understand? So can I just say it will be nothing but v by 2 is equal to e raised power minus 2t. Why do we exactly do this step? In order to find the velocity in terms of time only, because we are supposed to find velocity in terms as a function of time only. So that's why. So v is nothing but 2, take it over there, e raised power minus 2t. So velocity in terms of time as a function of time. Find. Now the second thing is, we need to find the position as a function of time. Understand? So in that case, we'll be using this. V is equal to ds by dt. We do the integration. If velocity is given, and you are supposed to find position. You are supposed to find displacement time relation, position time relation. What you are supposed to do, integration stuff. Do that. This is the application part of this calculus. Okay. This is the application part of the calculus. That is what I am doing. Okay, so this is v dt is nothing but a ds. Can I just write ds is nothing but v dt exactly over here? Fine. Now you tell me one thing, what is the value of velocity over here? Or simply you put the velocity over there and do the calculations and you'll get the answer. So how much velocity you got exactly? That is 2e, and it will be nothing but 2e minus 2t is equal to ds by dt exactly. Fine. Everybody understood till here? Come on, I need to know in the live chat, all of you. Come on, all of you. We need to get done with this as soon as possible. Already it took us 4 hours of time, okay? So now, do one thing. Okay, you can just write it, mention it in terms of x only. Now, so sx, it's one and the same thing. So it will be 2 e raised power 2 minus 2t into dt is nothing but a dx. Okay, now integrated from where to where? Now at x is equal to 0, particle was passing at x is equal to 0 origin with a velocity of 2 meters per second at time t is equal to 0, means at x is equal to 0, time was 0. After some time it has covered the displacement of x. I can say it definitely like that. So this is nothing but 2. Integration of e raised power minus 2t is nothing but e raised power minus 2t only, and differentiation of this in the denominator, that is minus 2. Okay, fine. So it will be from 0 to t exactly. So it is nothing but integration of dx is nothing but that is x only. Okay, I hope you're getting what I'm trying to say. This is x only. Now, can we just do one thing? This and this will cancel over here. So x will be nothing but minus e raised power minus 2t from 0 to t exactly. So x will be nothing but minus e raised power. First you put the upper limit, that is minus 2t. Then you put the lower limit, e raised power 0. Can I just write x will be nothing but minus, you multiply this e raised power 0, it is nothing but 1. So e raised power, this multiply this with this one minus 2t, and this will be plus 1. So finally I'll get x is nothing but this will be 1 minus e raised power minus 2t. So we got what? Position as a function of time. Position as a function of time. Third thing is, let's go for the third question. Let's go for the third question. That is its velocity as a function of time. Its velocity as a function of a position. You tell me, can you tell me the answer of this question? Its velocity as a function of a position. Now we need to find its velocity as a function of position. Acceleration is given. Use this formula. A is equal to v dv by dx. How does this come? We say A is equal to dv by dt multiply by dx over here divided by dx over here. So can we say A is equal to dv by, interchange this dx into dx by dt. So dx by dt is nothing but velocity, dv by dx exactly. This is A. Fine. Come on. We need to basically solve this question now. So what is that? So acceleration over here. So acceleration is given, that is minus 2v exactly. So can I just write it is minus 2v is nothing but velocity, that is v dv by dx, because acceleration is given. This particle is moving with an acceleration of minus 2v exactly. Take it over there. So minus 2v dx is nothing but v dx. Vv will cancel over here. Vv will cancel over here. This is minus 2 dx is nothing but dv. Now integrate. So when particle was exactly at origin, means at x is equal to 0, it was crossing with a velocity of 2 meters per second. Understand? And when particle has covered some displacement over there, its velocity was, for example, I would say v. So can I just write further? It will be nothing but 2, and it will be nothing but x from 0 to this x is nothing but, this will be what? This is v from 2 to v. Integration of dv is v. So can I just write v minus 2 is nothing but it is minus 2x over here, 100%. So v is nothing but it will be minus 2x plus 2 exactly. So v is nothing but 2 plus 2 minus this 2x. V is nothing but 2 into 1 minus x. So this is velocity in terms of position. Velocity in as a function of position. So done, done, done. I want you to solve this. Find the maximum displacement distance it can go. Will it reach the above mentioned distance? Understand? I want you people to find these two by yourself, and do let me know the answer of these in the comments down below. Okay, so, and we have this last question. That's why I'm going with the speed of light right now. So we have to basically solve this question, and once we get done with that, this question was asked in JEE Mains 2019. We'll get done with this question and we're done with this lecture. Okay, it's gonna take like 20 minutes. We will see how much time it's gonna take. Now, over here it is given as acceleration. Okay, that is 4t square plus 3t. This is all the application part of this basic mathematics. Okay, plus 1. Understand? So 4t square plus 3t, 4t square plus 3t plus 1. Acceleration is given. We are supposed to find the position time relation. We are supposed to find the velocity time relation. At time t is equal to 0, velocity is given as 5 meters per second. Understand? If acceleration is given, we are supposed to find the velocity. We do the reverse process. Understand? What we do? If displacement is given, we are supposed to find velocity. We differentiate ds by dt, we get velocity. If velocity is given, we are supposed to find the acceleration. We find dv by dt, we differentiate, we get acceleration. Now if acceleration is given, we are supposed to find the velocity or change in velocity. What do? We integrate, we get what? Change in velocity. If velocity is given, we are supposed to find the displacement. We integrate, what do we get? Displacement. I have told you this before itself. So same logic we're gonna basically use over here in order to solve this problem. That's all. Okay, now see what we're gonna be doing. Acceleration is given as this. Find position time relation and velocity time relation at t is equal to 0 when velocity is 5. Acceleration is given. You are supposed to tell me the velocity time relation. Let's find the velocity time relation first. So can I say acceleration is nothing but dv by dt over here? Clearly. So dv is nothing but a dt, clearly over here. Now integrate this one, integrate this one. Fine, because you will get that only. So can I just write that this is nothing but integration of from where to where? I would say u to v, or simply this is delta v. Okay, integration of small change in velocity is giving you the large change in velocity. Integration of what is this? This is 4t square plus 3t plus 1. Fine, and this will be dt. Now what is this delta v? Can I say this is v minus u exactly? And this will be nothing but integration of this one. This is 4t cube by 3 plus 3t square by 2. Okay, because integration of this will be 4t cube, 2 plus 1 is 3, 3 by 3. 4t cube by 3 upon 3t square by 2 plus t. It is saying that initially, what was its initial velocity? At time t is equal to 0, its velocity is 5 meters per second. You can put from 0 to u to v on 0 to t. You can do it like that also, not a problem. So this is v, initial velocity was 5 meters per second. Is nothing but that is 4 by 3 t cube plus 3 by 2 t square plus t. So finally what we'll get, that is v is equal to nothing but 4 by 3 t cube plus 3 by 2 t square plus t plus this 5. Take this 5 over here. So this is the velocity as a function of time. Velocity time relation. This was the acceleration time relation. This is the velocity time relation. So we are done with this one exactly. Okay, camera is changing focus. Yeah. We are done with this one. Okay, now is it fine? I just need to know. Now, So this is the question that is given. X of t is equal to at plus bt square minus ct cube. JEE Mains question 2019. The position time relation is given like this. We are supposed to find, for example, this is a particle. Understand, this is moving. Its position time relation is given like this: at plus bt square minus ct cube. Okay, this is moving. It's a displacement time relation is given. Understand, displacement is changing with time. Displacement is changing with time. And when particle attains zero acceleration, we need to find the velocity. We need to find the velocity. When particle exactly attains zero acceleration, we need to find a velocity at that point of time when it has zero velocity. So this is moving with this acceleration. This is moving with this acceleration. When particle attains zero acceleration, this is moving with this displacement time relation. This is having this one. So when particle attains zero acceleration, when particle attains acceleration is equal to 0, we need to find velocity. Okay, we need to find velocity. Okay, at that point of time. So how can we exactly solve this question? I just want to know. Okay, solve this before I do it. Let me show you exactly. Come on. Now see, how can we approach this question? So first of all, what we are supposed to do is we need to check at when acceleration is 0, what is the velocity at that point of time. We'll do one thing. We'll find the time when acceleration is 0 and we'll find the velocity at that time only. It is one and the same thing. Understand? We'll find, for example, t is equal to 2 seconds. I'm saying at t is equal to 2 seconds, acceleration is 0. So what is asked in the question, that is, when acceleration is 0, find a velocity. Now, we find a time, we'll find time. At that time, we'll find what if the acceleration is 0. Understand? We'll find that time where acceleration is 0. And we'll find the velocity at that time only. It's one and the same thing. That means we got the velocity when acceleration was 0. Understand? This is the logic that we're going to be using in this case. Now see how we're going to be tackling in this one. Let's find the velocity first. In order to find the velocity from this one, how can we solve this? So can we say velocity is nothing but dx by dt over here. So differentiate this equation. So it will be nothing but a plus, it will be 2bt, a plus 2bt, it will be a plus 2bt minus 3ct square. Okay, fine. Now the second point over here is we got this velocity. Let's find the acceleration. So acceleration is nothing but that is a dv by dt exactly. If we will find the acceleration over here, how can we do that? Differentiate this once again. We got the velocity by differentiating this x. Now differentiate this once again, the rate of change of velocity with time. So it will be nothing but, can I say it is nothing but that is 2b minus 3c minus 2 into 3, that is 6. That is 6t. I changed this color. This one, yeah. It will be 6ct exactly. Fine. Now, we are supposed to find when acceleration is 0, find velocity. We'll find the time when acceleration is 0. So put this equal to 0. Because we can find the time only from here. So it will be nothing but 2b is equal to 6ct. Understand? It will be 3t. T will be equal to, that is, b upon 3c. Understand? So t is nothing but b upon 3c. So at this time, acceleration is 0 because we put the acceleration 0 over here in that case only. So it is nothing but at this point, acceleration is nothing but 0. Acceleration is nothing but 0. So at this point of time only, we need to find, what? Velocity. So that will give us the velocity when acceleration is 0. Let's find the velocity in this case. So t is equal to b by 3c. At this point, acceleration is 0. Let's find the velocity at this time only. So what was the equation for velocity? That is, v is equal to nothing but a plus 2bt minus 3ct square. A plus 2bt minus 3ct square. Okay? A plus 2bt minus 3ct square. Okay? a plus 2bt minus 3ct square. Okay, now put the value over here. A is equal to a plus 2b. What is the value of t? Over here acceleration is 0, that is b by 3c minus 3c into b square by 9c square exactly. Fine, so it will be c 3 3's and it will be, this will get cancelled. So can I say v is nothing but a plus, it will be 2b square by 3c, it will be minus, it will be b square upon 3c. Okay, so v is nothing but a 2b square by 3c minus b square by 3c. It is b square by 3c only, that is b square by 3c only. Fine, so this is the velocity when acceleration is 0. Because why? We got the, see, the approach in this question was basically we got the velocity, we got the acceleration, we got the time when acceleration is 0. At the same time we found the acceleration, at the same time we found the velocity. That means when acceleration is 0, the velocity is this. Okay, so yeah, this was all about this one. Yeah, I'm getting okay. So thank you so much. It was nice interacting with you people. Okay, I'm very tired. I'm done. It's all 4 hours of lecture today itself. I was not expecting it will go till 4. I'm very tired. Okay, so this is basically the JEE Mains 4th attempt. The question paper solution. It has already started on Unacademy. Okay, so you can definitely check, the link is in the description below. You can definitely go for this one, and if you want to basically solve the papers with the teachers itself, so what they are solving right now, should go for this one. It started from today itself. So this is basically, you can download the Unacademy app. This is my number. Sorry. You can this is how you can come in our special classes. So join our download the Unacademy app, sign up with the number, find me over there, search me, this is my username, and these are the special classes completely for free. If you find this interface, it will ask you for a code to unlock that will be this Yawar, use this Yawar. And this is the batch we have started recently on Unacademy, that is completely in English language. Okay, and if you find this, do let me know in the comments down below which part of the lecture was exciting one. Okay, and this batch is completely in the English language. This is taught by some of the top faculties from different states. This is for class 11th and 12th JEE Mains and Advanced 2023. Okay, and this is the Shine batch for class 12th JEE Mains and Advanced 2023. You can definitely enroll in this one, taught by some of the top Telugu educators. And apart from this YouTube platform, we have our own platform, that is what we call the Unacademy's platform. Okay, you should definitely go for this one. If you can, there will be live classes, weekly tests, structured courses, unlimited access. And in this Iconic subscription, you'll be getting personal guidance, test and ads, experts guidelines, study material, study planners. You can follow me on Unacademy. This is my username because we are coming up with lots and lots of courses. This is the IIT JEE Iconic subscription. And you can take this plus subscription for 12 months, 18 months, 24 months, 3 months also, 6 months also. EMI options are available as well. You can use my code YAWAR in order to get the maximum possible discount. Okay. And if you take this Iconic subscription for 12 months, 18 months, 24 months, you'll be getting the maximum possible discount by using my code. This is the IIT JEE Mega Combat Scholarship Test. This happens every Sundays. Okay. Next, it will be on 29th of August. 11 a.m. and you'll be getting the if you get the ranks according to that, you'll be getting the offers accordingly. And if you find any of my content as inappropriate, you can definitely report there. The link is in the description below. Okay, thank you so much, and subscribe to this channel, hit the bell notification, like this video, share this video with your friends, and do comment down below which part was the exciting one. Do let me know. And thank you so much. I'm very tired. I need to go right now. I need to eat something. Thank you so much. Bye bye. Take care. You also go to sleep. Thank you. Take care. Bye bye. Have a nice night. Thank you.